do that. So you sent me this, which basically I put it into two viewports so we can
Yep.
see it side by side. So what it looked like that you were doing from this is the same type of thing that Drew is trying to do. Now I went through and turned on all the layers. I think you had it frozen except for the existing ground. So it looks like you were doing exactly what I was telling Drew that you can do. You're up here is that you're starting to build you're building this terrain model based on these. Every one of these are sections and you're stitching them together. And now technically you should actually go through here and build, from here to here to here, and put break lines in those areas as well. Although they're probably, to be fair and realistic about it, they're probably let's say they're probably not going to look at in plan view. So the reason you would do that from here to here is to keep things from triangles from forming across when you want them to form along linearly along the edges of this. So
typically what we do is we'll actually draw a typical section and send it along the center line and then put this on top of it. And then we basically use these sections to catch the break lines only. So the typical section is doing most of the work as far as the triangulation, but this is just catching like break lines in the slopes because it's easier. We think it's easier to do that instead of figuring out all the kick points on the typicals.
That would be exactly right. So you're actually generating the break lines of the finished roadway.
Right.
And using those as break lines to go into this as a modeling device. And so, yeah, that'll work. But I mean, you can see like up in here where it goes, I'm presuming around a curve, and down here as well. That's pretty sparse data.
And there's a bridge in the middle. That might be part of it.
Oh, yeah. Okay. Yeah, that would be in there or in here. Now you can make a discontinuous surface. That's not a problem either. But so, let me say, so what you could do in terms of the takeoff workflow, in terms of build existing, build design, you just put those into place, just like you've done here. And now how did you, what did you use to make the alignment of these sections? Did you compute and display the center line? I saw you had a bunch of center lines there as well.
Yeah, so there's a file in there called alignment, and that's all displayed. But basically, we take the data from the plans and program the center lines in.
Okay, yeah. So we had one am I in? I'm in cross sections now, so it's this one. I don't want to do it like that. I'm going to X-wrap. That's why it was doing that, because that was set the way the last time I ran it. All right, so there they are. Yeah, there they are. So that is the sections here superimposed on it from these sets of data. I'm just, are you starting at the bottom and going up on the left first?
Correct.
Or
correct?
Yeah, so this really represents that, right?
Close. We
or maybe
finished grade, but yeah.
This is finished.
No, that's that is finished. So it comes from the finish trace layer on the other sheet.
Oh, okay. All right. So In any case, yeah, that, I mean, that is an approach. I can say that because your sections aren't always going to go nicely the same distance out left and right of a center line or a profile grade line, whatever. They use a lot of states, they don't use the center of the road to do the center line. They'll use the, one edge of pavement perhaps. Just partially for safety so that they're not out there trying to survey a center line there. But that's all right. So that's a separate. Separate dimension this way. Yeah. So yeah, and that's really about as good as you can get it, because there's nothing in any of this information that tells you what happens at 4275 or at 4325, et cetera, et cetera. Right. You don't have any of that information. I guess that's the other, that's an intersection there. Whereas if you had that existing ground and you've got these center lines and profiles, and you can model, including the intersection, you can model that whole thing as a series of prismatic surfaces, including the subgrades. And it'll give you a station by station summation report of all your materials. It can even compute a mass haul diagram, so you know where to start and stop your hauling from your excavation. It can do all that, but it needs that existing ground to be able to do it. Mm-hmm. Well, let's see. There are other sources of existing terrain. You are in Dayton. It's fairly flat.
Yeah, honestly, we probably have like the original survey CAD from this project. It's just in the microstation dump from the designer. We typically don't pull it for this, but I understand how you're saying. Yeah, it'd be useful.
Oh yeah, that would be what I would do entirely. Is like I said, you've got the data to be able to build this alignment, these alignments. I would imagine then you also have the profiles as well. So when we start talking a little bit about this on this roadway design stuff, that's really, what do we need? We need that alignment, that center line. We need a profile. Then we need a template for that road to follow. And if we want to process it, then down here it says optionally we start with a surface design that defines the existing ground so that the roadway processor can tie out the sidelines. Now you can produce the finished roadway end to end, including through all those intersections, including lane widenings, changes in the template, anything that you have, you can create that entire structure. But without an existing ground, you won't know where the last edge out of your design template, either your cut and fill slopes, there's nothing to catch. They won't have anything to target. So in that sense, it'll do. And it also, and it goes around curves, it puts a circular sweep on those things, and you can tighten up the template drop in those curved regions, but it doesn't know how to take from the last edge of that design. Let me get up here in some of these other, is this a separate layer? Can I turn this off? Yeah, there we go. So your last edge of this final, once it comes out to right here, it doesn't know where to go with this. Okay, so you can build this whole structure out to here and it just basically lops it off on those edges. Well, now there's a lot of material out in there, as you can see, right here. So, it's hard to say it's almost a requirement, but it's not really a requirement as much as it's something that's optimal. And that's why I say down here that it is optionally, because it will process without a surface in the one sense. When you run RoadNet to process your road design, if you haven't declared a terrain model for the existing ground, it will stop, throw an error, and it will say it can't go any further till you do that. Well, let's say you don't have one. Well, you can just take any given surface, just make a 3-point dummy surface and give it a name and use that. And then you turn off, processed side slopes, and it knows to ignore it, but it does look for it. So anyway, that's sort of the way around that. But again, this is so much work to do. And again, you've just got discrete slices and you're relying on just a straight line interpolation along those features. And again, well, of course, you're saying you do put in the break lines from the design template, and they are 3D, so they'll carry those edges for you if you add those to it. So that might not be too terribly bad. The problem is you don't have an existing to tie it to. So I think if you...
Well, here's the deal. Basically, those lines on the section file on the right, those all come from my interpretation of the cross sections on the left. So you'll see I have a layer in there called 00 trace, I think. And that's basically tracing what I want to go into that. And we take it down. So the very end point of that is the existing ground on the cross section, which at that point, it doesn't matter so much that it's, 50 feet away or blocky, because it's just the side slopes. What we really care about is making sure our curb looks good and all that fun stuff, which comes from a specific typical section. Once you get up break lines, being blocky hasn't been an issue for us so far. But if you tell me there's an easy and quick way to change that, I'm all ears.
Well, that's what I'm saying. If you have a target out here, then you run this through the road processing, and it will target the catch slopes out here plus all of the side slopes. We'll run through a couple of examples with that today. That's really something that's typically done in the civil class, but both you guys are doing that kind of work, so it might be beneficial. And like you can put all this stuff in your template as part of that process, including the sidewalk and all of the subgrade materials, the curbs, and it will accumulate all of that material, all the sub base, all the stone, the asphalt, the concrete, and the stone under the sidewalks. All of that stuff will get accumulated through that entire roadway and reported to you as well. So if you do this process that you're doing here, you are, again, basically just tracing the top, right?
Correct.
And then you're letting this go out. So what this, let's say the one I'm looking at is this one. Then you've traced out to this point right here.
Yep.
And that's where this one is. I mean, you can really, I don't know if you trace over that, right? I'll show you a quick, if you're doing like click type of tracing, I'll show you a quicker way to do that here in a minute.
That'd be sweet.
So let's say, let's say I'm right here with this one. These go out here. So like you say, this flare stuff out here is okay. But again, I mean, and you're willing to live with that, but you're only getting the top surface. What are you doing about, excuse me, about the materials? Because when you look at, let me see if I can find an example of this. Looks like that is entirely under. Those are what, like concrete mud mats, it looks like you're putting in. Under the ground.
I'll tell you what it is. I'm looking at the typical here.
Well, yeah, I mean,
That's a stabilization.
yeah, it's what we call here in Pittsburgh a mud mat. It's to get rid of unsuitable soils. You got to basically shore it up. You basically got to build a platform to build the road on. But see, here's a situation of something you won't be able to figure out. Here's a section of this road. Now you're building all of this. Okay? Now you could go through and collect up all of the subgrade materials, put them in there as well, and build them as their own little surface also. Just like you did this for the top. Well, I guess you could take this. You do have this line here, so you could get that and that. Are you doing those also?
Typically not, but that would do what you're saying for sure.
Well, yeah, and the reason you might want to do that is because look at all of this material. This is all fill, okay?
Right.
All the way up, whatever this scale is, I don't know, 1 to 1, but whatever that thickness is, you don't have anything with this approach of just getting the top surface that tells you that. And otherwise, now you might be, when you do this top surface, you end it here, you do the top surface and end it over here, which would be here and here. And if you just straight line in between it, well, what happens if this ground actually, maybe it comes up like this and then comes back down? You don't know that unless you do the whole section. So you could take this line, this 2D, it's a 2D polyline that looks like, I think all of them are. Yeah. So you could take this and from over here, after you do the extents of the finished grade, which would be like right here and over here, and that represents here and here, then you could take this entire outline and drape it onto this. See how that existing ground continues on beyond it? So you can drape it right there to clip it and either physically trim off the line work or just use that as a surface boundary. Now, I'm thinking here a minute, because it's not just a matter of drawing that. These again are 2D polylines, and what I'm looking at here is not in 3-dimensional space. It's flat on a piece of paper. If I wanted it to actually be a 3-dimensional entity, I'd have to pick this thing up and rotate it toward me 90 degrees, so it's sticking straight up in the air, right? So that I've got a Z difference from here to here. Right now I don't have that. So when you do that, what are you doing with that? Are you creating 3D polylines and then rotating them into place? How are you making this become this? you're not just measuring and then drawing and measuring and drawing?
Oh, we make a section file.
Okay,
So roads, draw, create sections
yeah, okay,
from
so
the
you're,
screen entities. Yeah.
right, okay. So, well, yeah, that should be able to do it, even if you're not, you wouldn't, you wouldn't have to do a bunch of clicking on that either, as long, except you don't
You got
really,
to click like a base point for each one, but it doesn't take that
yeah,
long.
right, right, but you're not clicking every turn point, like back of curve,
No,
top of curve, all of that, okay, all right.
no. But I mean, you're doing that with the tracing, so you're still doing it at some point.
Yeah, but I'm trying to figure out why you're tracing it.
Because the way we do it now is what I'm trying to say is we just care about that existed or the final finished grade surface.
Mhm.
And that's what we put on the dozers, and whatever else hits, it hits, as far as the side slopes.
Yeah, but you're saying you trace that top surface. When you build your section file from screen entities,
Yep.
that'll generate that. You shouldn't have to draw. You shouldn't have to trace, is what I'm getting at. I mean, that'll generate it as long as you've got, as long as you've got this thing defined. See, that looks like,
That's what I traced, that line there.
oh, I see. Let me see. Yeah, that's zero trace. All right. So if that's not there, I'll temporarily erase it here. You should, like, that should be closed off unless you're going to grade down like this, whatever it is you're trying to grade. But when you do your section file, it should read all that and create that for you. Let's say that you're still doing that you're doing this trace and then you're transferring that into the section file. Is that correct?
Right.
Basically, when you're done through tracing, you are let's see, you're taking this and I don't, maybe you have a different grid. Is that my center line reference in there? Maybe that. If I select similar, and then if I isolate, let's see, P for previous. Yeah, all right. So you're doing something like that.
Mm-hmm.
And then you're running that command to create section file from screen entities. Okay.
Mm.
So what you could do, I'll show you a quick way to create this trace line without having to click it everywhere, is I'm going to, so I'll go ahead and make that my current layer. I'm going to go up here. I'm just going to move this out of the way just so we can compare it. Okay. And now is this normally closed off? Maybe something just got deleted.
Usually it is. I don't know why the designer sent it like that.
All right. So I just may have picked one that just accidentally got. All right. So when you have your sections that look like this, let me freeze these and that maybe that. So that looks like the extent. Now, where does this tie? That's my existing. ground. Is that, let me do that or this. Okay. As well make it clean here. Looks like the layers are set up nicely. I'm trying to see where this would, where would you know? Let's see, where did you stop that? It came down, went all the way out to here. Okay, so it stopped out like here.
Yeah.
All right. So what you would do in this case to trace all that is you would determine those edges, make sure there's nothing else in the way. You would draw a 2D polyline. It can be, doesn't have to be 2D. But you go out to where you're going to start. You're going to grab that corner and you're just going to come up here and grab across the back, come up here to this other end, and then tie down to the last one that you're going to use. Okay, so you've got a region defined with the finished ground as one edge of that region if it were a closed polyline, right? But remember yesterday when we were talking about that draw shrink wrap, if you do a boundary poly, and let's put this on 0, 0 trace, make it a 2D, pick inside, we'll say, okay, we'll click, and that's done. And now this, which I would normally just leave in place, I would say, I would come up here and go, here's my erase polyline segment, remove polyline segment, and just get rid of that one, and that one. Now this should exactly match the one we moved up here for reference. And as long as you hit all the same points, it will. See there, it's exactly it at the top of each other. So, you know, click on the end, click, click, click on the end, draw a boundary poly, click in the middle. Now, well, if you have, you know, something else sticking up in here in the middle, you don't want it in there, you have to get that out of the view. You can't have it, or if you have grid lines showing, you know, it's just like you're doing a hatch. As long as that's clear space in there, it will define that other edge, and then you just get rid of the 3 edges.
I'm just curious, did that pick up where the sidewalk, the little gap between the edge of the grading and the go on the, yeah, on the other side where you asked about it earlier? Yeah, did it pick up that?
I closed it off.
Okay.
I drew that across there, yeah. And if it's not there, it will pick that up. It'll scoot down in there and then come back out.
Right, right.
Okay. So, but since you were saying you were just getting the top surface, you didn't want that. So that's what you have to do. You have to make sure it's sealed, if you will, or waterproofed across the entire top. You know, if there's a hole in it anywhere here, if there's a little hole in here, you know, it'll leak down in here and it'll mess it all up. It could fail the command, or it could just give you something weird. If anything in the subgrade, you know, sticks up through it, you know, you might need to trim those off. I would just, you know, take a cursory glance at it. It looks like this was all set up. You could do that on every one of these. You know, there's a good example. Oh, come on. The mouse is acting goofy. All right, so there's a good example. Again, I'll go from here. I'll just come across the back and come down to, is that there, or do you take it on out? If I take it on out to here, then I have to make sure that this is out of the picture. So I'm going to hide by selection. I'm not erasing it. I'm just taking it, change out of my view. And then I'm going to draw a B poly. It used to be one of these icons out here. Draw a boundary polyline. And just click done. I'll move this now just up like this. And here's that original that I used for my boundary. No longer need that. I'll delete the segments here, here, and here. There now is exactly that surface along the top. Okay.
All right, one more time, what command is that to do that?
Okay. Do you have this file loaded?
Yeah.
All right. I'm going to stop my share and I'm going to invite you to share, and I'm going to just watch over your shoulder and I'll talk you through it. I just want to make sure that you know where to go about getting this. So window up, there we go. Up. I'll stop sharing this. Now you share your screen. You know how to do that part, right? You know, share your screen.
Yeah.
That share screen button, just click it, choose the screen you want, and then don't forget to hit the share button after you do it. There you go.
Got me.
Okay, so so the first thing you want to do now, I said you have your grid on, and that's fine. If you want to just really don't let it hide any drawn elements that are that might be lurking. So now we want to freeze off the layers that you don't need. Yep, you can do that. Yeah, you can do it. Yeah, you're pre-picking, which is fine. The other command is it just picks it. It freezes it as soon as you click it. That's
Which one's that?
one. Freeze layer by pick. Okay.
Yeah.
Now pick, yeah, the fence, the text. Now anything that's underneath won't matter. You can leave those things showing. You don't need to freeze those off. Just anything that's going to be above it.
That should do it.
Yeah. All right. So you're going to close that off. And now keep in mind, it's very dark looking, but you've got that grid line above. So you don't want to be able to keep that. You don't want that in your way, but you'll be able to fix that. That won't be a problem.
We'll get rid of it.
All right. All right. So there you go. Now you're going to simply draw a 2D polyline. And I would suggest putting it on just any given layer you want. Now you are using the CAD 2D polyline, which is fine. There are some options that Carlson's draw 2D polyline gives you that you don't have in this one. There's some additional options, like there's the follow command and continue command, all that kind of stuff. But anyway, it doesn't matter. Whatever you use to draw a polyline. So now start at the endpoint there on the left, and you're going to go up and over and then come down to that endpoint and click to stop. Now you're going to draw, it's on the draw menu, and it is right down in the bottom half. You see that shrink wrap entities? It's a line right above it. This is boundary polyline. Now that layer name, go ahead and choose that layer name up there as 00 trace or whatever you normally use. There you go. That's fine. Click OK, and then just click. It's done. Just hit enter. Now, you can do that. Let's say you prepare all of these little boxes around all your sections, then you just click, 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 and do them all at once.
Mm-hmm.
Then
so I can go click here, click here, click here. Yeah, after all the boundaries are gone.
Yeah, I mean, you click once inside each one of those.
Right, that's what I mean.
Yeah, that's exactly right. Now, what you have are, you have a closed polyline on layer 00 trace, and you still also have that original white polyline underneath it. So what you want to do is you don't want to erase this entire closed polyline. You just want to get rid of these segments, and you can do that any choice you have. You can break it and then get rid of it, or I find it easier to go, and it's on the edit menu. I take it from my polyline toolbar because it's easier to find, but this is why, because it's so deep. Go to edit polyline, then go over, and it's a pull right. It's up in the midsection there called remove polyline. Come on down the middle part of it right there, and say remove polyline segment. Okay, click once there, click up, yeah, on each of those three that you want to remove. Now yeah, perfect, that'll do it. Yeah, you don't even have to get rid of the back one as long as you've got the other one broken. Now that polyline is what you normally go click, click, click around to do.
Right, that's nice.
Yeah. Now, again, remember, it can fail if there's a hole in that's anywhere, like on that sidewalk. Now, it would have just gone down that little bit and back out.
Right.
But if it's a complete discontinuity, it will not even complete the command because it leaks out the bottom and never stops. It never finds a boundary.
Right.
Again, if you remember or understand how the hatch command works, then that's really what you're drawing. You're hatching that pattern, that you're hatching that interior space, and then throwing away the hatch, but saving the boundary of the hatch.
Right.
That's what it's doing. All right. Now, in the case over that section over to the right where you've got the guardrail sticking up, see, that's another one. If that's all on its own layer, you would freeze that layer too. But now what I did in your case on the one that I showed you on my screen is I did a hide by selection. If you look on the view menu, I think it is, you see those, I don't see them there. Let me see.
Here we go.
There it is. Yeah. Yeah. Hide by isolate. Now in regular AutoCAD, that's a right click menu choice, but then it's called isolate objects. And you can either isolate the things you select, or you can hide the things you select. And then of course you isolate, you restore all of those things when you go back and choose that. Again, you would do it off your view menu, or you take it off your layers toolbar, whichever one you have out and about. But anyway, that should save you a few steps. Okay.
Yeah, I'll take it. Thank you.
All right. So let me go back to sharing mine here. And I'm going to turn my video off so I can eat my peanut butter sandwich without, no, I'm kidding, but it saves a bit of bandwidth. So we're not pushing video. So now, see, there's that guardrail. I'm just going to now restore back. I turned that back on after I did the hide objects by selection. So I put it back.
If I can interrupt real quick, what is your up there? You've got a toolbar up there to like hide layers and stuff like that. What toolbar?
Up here? That is called the layers toolbar. Okay. And it has things that there's no layers menu, of course, right? You see these up and it goes from there to there. Those are primarily from the view menu. And you see that thing that says layer control, which is not even on that toolbar. That's the button that's beside this object properties. That's this one right here. And that's more, and now I'm in IntelliCAD, of course. Now you've got the same toolbar, I think, in your R9 series, Drew, as well. And there's also an IntelliCAD layers toolbar. I'll show you that in a second. You see it's very similar now, but these tools have been around years before AutoCAD even came up with these concepts of isolating layers. And so they're here. I've got set current, change layer. Now those are things. Set current is also on down here. This change layer is up here as well. But these first ones to that first little vertical bar, that little vertical bar right there. Those are from, it's got isolate layers, restore layers, then freeze layer by pick, which instantly freezes it as soon as you pick something on a layer, or freeze layer by selection. You pick, and when you're through picking, you hit enter, and then they all freeze. I don't know why there's any particular need to have it that way instead of the other way, but that's what you got. And then, you know, thaw, there's isolate and restore. Restore just unisolates what you did. And then there's thaw/on all layers. And that just globally takes every layer, thaws it. If it's frozen, it thaws. And if it's off, it turns it on as well. So that's sort of a turn everything on. You might want to save a layer state before you do that, or if you do it just to see what's out there, and then you do an undo to put it back like it was anyway. Now, the remainder of those tools, there's this one here, and I never use that. That's lock layers and unlock layers. I usually do my layer locking from here. I'll select that, and then I'll go over here to this column, but that does it with the toolbar. I don't do that very often. But then here you've got just like we had freeze by pick, here's turn off by pick and turn off by selection, and then turn them back on. So that does this does the freeze variation, where this does the on off. This is freeze thaw, this is on off, same type of thing. You can set a particular level by picking. That does the same thing as this one, which says MOLC, which means make object layer current. And that's an IntelliCAD button. That's not a Carlson button, but this is on here. And then finally, this is from our view, show hide by selection. There they are. Now, here is something to notice about this if you're starting to really pick up some steam and move ahead with your learning on the software. When you see a command in the menu, and maybe you're comfortable with where it is, some commands have little icons beside them, some don't. Of course, the pull right menus don't have any icons over here, but when you get to here, let's look down here at one of my very useful and most productivity set of tools that I find are on these polyline utilities. And sometimes they have to do with removing segments, either remove a polyline segment or remove a polyline vertex. So, you know, and yeah, I know I can grip edit and right click after hovering over a grip and take them out individually, but this is much, much faster, and I don't have to snap to them. I just pick near and it takes them out and instantly just walks me along, and I can do them out of order. It's just a really great set of tools that gets rid, you know, Autodesk wrote the polyline, the p edit command, and it is so arcane because some programmer decided he's going to figure out an algorithm to make one command do every kind of edit that you can possibly think of to a polyline. And it has so many sub menus underneath it on the command line. It's just a pain in the tuchus to get anything done. And to remove a vertex, do you think the programmer decided to call it remove a vertex? No, he called it straighten. And you have to first go into edit vertex mode, and then you have to step your way to the vertex you want, or to the vertex before the one you want to get rid of. And using the next button, hit enter until you're ready, and you're sitting on the point before the one you want to get rid of. And then you type S to straighten. And now you go into another sub menu, and then you go next. You go to the vertex that is beyond the one or the ones that you want to get rid of. And then you type G to go. And so that straightens it between where you started and where you stopped. And then you have to X to exit up a level, X to exit up a level. You know, it's just arcane. So these tools are very helpful to me, and they really do what I'm wanting to do. And I can see them by icon. There's a picture that shows me, hey, there's an eraser over top of a red dot that's remove the vertex. There's an eraser over top of a red segment that's remove a segment. All right, so what I'm getting at though in terms of this is that it's not a very useful command if I have to go click on the edit menu, click on polyline utilities, click on remove polyline, finally get to it. So the little shortcut to make you aware of it is that, and you see these two down here have the icon, but these two up here don't. Okay. That means that there is, if you see an icon, that means it exists on a toolbar somewhere. It doesn't tell you which one. Okay. And you might have to look up in the help system, or you might just have to guess after you play around with the toolbars and see where it lives. So these two are not on a toolbar anywhere. I'd have to always do this from a menu command or type the command, which you can see down here on the status bar when I hover there. That would be RMDUPLWORK, remove duplicate line work. All right, again, another mouthful. There is a CAD command, native CAD command now that Autodesk came up with. I think IntelliCAD has it also, but it's called Overkill. And that does the same thing. But anyway, the point is it is a polyline function. It's really a great tool. So I turned on my, if you see, I'll hover here and you see this is polyline. So that's my polyline toolbar. But I have here extend by distance. Oh, there's that boundary polyline. That's the same thing as that draw boundary polyline right here. I knew it was out here somewhere. I couldn't remember. It's right here. So you can do that, Josh, as a place to get it if you use your toolbars. So there's extend by distance, boundary polyline, join nearest. None of those are on the polyline menu. I think edit has, there you see join nearest. Extend by distance is up here. You see it's buried a little bit. So, but it's out here because it's so useful and it's handy. And then I've got those reducing the polyline vertices. That's a weed command that strips out vertices that you don't necessarily need. Its opposite is the densify. We did that yesterday as an example, and smoothing, closing open ones, etc. But and the rest of these are your polyline edit functions. And right there is also that offset 3D. That's why I couldn't find it. That used to live on the grading menu, and then they moved it to this with this in some recent version. Yours may be there as well, but in any case, they're there, reversing the direction of a polyline. So these are all commands that are buried in various menus, but they live out here on one toolbar. So that part's useful to me. I get a lot of use out of it, and I do this quite often. And my point behind all this is, if you find a command that is really useful, you're most likely going to find a little icon on it, which indicates that it is available on a toolbar, because it is a useful command. They want to make it accessible. So you're most likely going to find it there. And I would sort of recommend that, or I would encourage you to explore those and see if they're going to help your productivity, because as useful as removing a polyline vertex is to me, if I had to do it by click, 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 I wouldn't use it very often. I would just hover over the vertices and right click, delete vertex, and hope I didn't have too many of them to have to do. So anyway, that's all preference and work style and what suits your case. And you can turn those on a number of ways. You can right click up here in the gray spots. Settings, I think there's a toolbar manager. No, the manager, actually, you can set up toolbar configurations and load and save them. But the toolbar setup, you can do it this way, or you can go up here and right click and you choose, there's menus to show, toolbars to show, and there's different ones. These are the ones from Carlson. These are the ones from the C&G survey subsystem. If you're a surveyor using that part, most people are not. And then these are IntelliCAD or AutoCAD, if you're using that, toolbars separate and apart from the Carlson ones. And I told you they have their own, like here's the draw menu. And here is the layers. Let's see, there's layer tools. Oh, we'll just take a look at that one. I didn't see show toolbar, IntelliCAD DGN. No, let's draw. Yeah, that's the IntelliCAD DGN. That's the DGN draw toolbar. So, you know, you get a sense of what they do now. And this one's very limited. You can draw a point, a line, a polyline, a circle, text, leader, and a revision cloud. Not much to it. The draw command from IntelliCAD, line with a little arrow, which means you do a line, array, or an infinite line, polyline, multi-line. You know, I sit there and read them all to you, and you see all the arc commands, all the ellipse commands, circles, etc., etc. There's your helix. There's a 3D poly at some point somewhere, and all this mess. And so, you know, this is, there's a hatch. If I press and hold it, I get down to that boundary. That's that draw boundary polyline. Okay. So there's nothing wrong with using those. But if I'm going to draw a polyline using the old standard IntelliCAD polyline command, now this part's new. It asked me to pick the start of a polyline. So I can pick here and then click, click, click. But you see this option that says follow, that lets me pick another line. Let's say I'm going to come down here and I say follow. I'll pick this line. Okay, there. Up, follow. What's going on? I'm getting it to work right on theirs. Whereas Carlson's, and it's I can start it at a given elevation or pick something to set the elevation. I've even got a nice little thing here, is that if you're drawing, say, building footprints, you see this autocorrect for 90 degrees. So if I'm like here and I'm just, you know, I'm slightly off, see how that snapped it back? So that will, now if I'm, you know, going out here and I'm beyond a certain tolerance, it won't snap it. But if I look like that, now let's see, about up to here, that was beyond the tolerance. It's just, there you can see it snap, change its position. So you got some things like that. But the real key difference, in particular for surveyors, is this says pick a point, just like the IntelliCAD version, but it also says or point numbers. So if you're using Carlson coordinate points, you can use, not only give it a point number, but you can give it ranges of point numbers, like, you know, 3-27. So instead of pick, or 3 enter, 4 enter, 5, and, you know, you've got that flexibility using point numbers. So anyway, those are all there. Here is this layer stuff. These are all, like, here's the explore layers, and that's going to bring this guy up. But remember, it's more than just layers. It's everything in one interface. Okay, there's my external references. Now, so that's the same thing that's out here called layer control in the Carlson toolbar, but it's that same command. It also has this isolate layers, which is the same as this one up here. And then you've got unisolate, which is same as restore. There is a layer, or there's your pick, freeze, and thaw, your pick on and off, your locking. There you can delete a layer if it's empty. I think it has to be empty. No, actually that deletes a layer and all of the entities on that layer. I didn't know you had that. That's from the IntelliCAD. I'll show you the difference in that one. And what we have here on ours is erase by layer that does the same thing, but see a little pencil eraser in a stack of layers. But again, that's on our edit erase menu, but it's out here in my layers thing. So if I say erase by layer, I get a lot more flexibility here. I can pick it from the screen, pick it from a list, and then I can filter only the types of things that I might want to erase off these particular layers. And then when I select a layer, I can do multiple layers and all that kind of stuff. And you know, it's just a real handy way to do some global cleanups on stuff, particularly if you're doing repetitive, iterative type designs. You're doing some what ifs. You're drawing a bunch of stuff. No, they didn't work. So instead of having to go through and slug your way through selecting a whole bunch of items, if you know they're the only thing on the layer, then you can do it that way as well. Okay. So that's the long answer to where did I get the tool? It was up here on this layers toolbar or polyline toolbar. But that's a way, as you're learning those, take a look at the ones that do have icons, mean that they exist on a layer somewhere. And right clicking over here to choose it, or the toolbar setup. Now this one's a little bit, I'm not sure if they've changed it. I'm not sure if it's different on yours, possibly, Drew, because of the R standalone. But this comes up and it lets you check off these layers, and it looks like, wow, I've got a great lot of choices, but I don't see those DGN layers. I don't see the IntelliCAD. You got to remember that up here at the top is where you choose. So I've got Carlson DGN, I've got iCAD DGN. I don't even think this one's available through this right-click interface. So these are basically a lot of the same tools. Let's see, here's polylines. Let's see what that looks like. All right, so this is a polyline toolbar. It looks very similar. It looks actually kind of identical. Let's see. It's identical except for setting the polyline origin. It's not available. Whether that means that it's not available in MicroStation and that's why it's on the toolbar, I don't know. But in any case, that's where it is. And if you're really creative as a programmer type and understand the esoterica of all this setups, you can create your own toolbars and stack up commands and put them on there. It's just, again, you know, and I used to be a programmer. I used to do database programming. I understood things back then, but now it's so far beyond me that I'm glad somebody else is doing it. I'll pay extra to get the pretty pictures on the toolbar. So that is sort of an addressing, if you will, of some of this stuff that might help streamline things for you a little bit. So that gives you that top surface with that draw boundary polyline. Now, if we had, oh, I'm going to switch out of this. I was in Hydro last night.
I can, maybe before we get off the buttons topic, I've got like a row of, file, edit, view, draw, all that stuff. And then I've got another one that like opens the ribbon. Is it possible to get rid of the tabs that open the ribbon?
Yeah, you should have, well, like if I switch to ribbon here, and so here's my ribbon now, I can cycle that through. See, AutoCAD has this, doesn't have, there's a way to there's a way to crunch this down to where you only see the titles of the panels, but you still always see the panels. I don't know what it is right now, but
So there's no way to get rid of the titles of the panels.
yeah, there is. I'm just showing you some options of where they are. So in IntelliCAD, the way to do that, to close the ribbons entirely, is to switch to menu bar. Okay. I don't know that that's one of your choices in your version. So let me real quick, if you can.
I got it.
Okay. Now you can also do, you can also do on the command line, you just type ribbon close. And so when this comes up, yeah, see, this is a different interface. We'll just open that. Is fine. I don't think there's anything in it. Yeah, so in this case, these are toolbars here. Yeah, so there's my roads and such. I don't know that there's any. I don't know where that would be, and I don't see a. Here's my settings. So you said did you find it? Did you?
I'm all good.
What did you use to fix it?
I just needed to switch to ribbon or switch to menu.
When you right click it, you have a switch to menu bar.
Yeah.
So you're using R12, right?
This is Josh. I don't know what's up with Drew.
Oh, I'm sorry. You know, yeah, I'm sorry. I'm watching the little frames light up as to who's talking, and Drew was on the bottom yesterday and you were in the upper left. That's what's happened. That's what I think I'm talking to. I'm sorry. Yeah. So yeah, in any case, in either of those two cases, you could just type ribbon close. So yeah, sorry about that. And the AutoCAD, if you were using AutoCAD instead of IntelliCAD, there's a, I think it actually says close ribbons on the right click. So it's just a matter there. But again, you just ribbon close as one word command, it'll do the same thing. All right. All right. So now Josh, now you were saying when you draw that little 0, trace line there, whichever method you use, you then go into this create sections from screen entities, right?
Correct.
Have you ever run this command?
I have not, but I'm sure my other CAD guy has.
Yeah, so that one actually does it from multiple polylines on different, like if you know the layers or you individually select it. So help me out with these grids. Let me turn everything on so I can see what I need. So this is my center and this is the, is that my reference elevation line or no, down here is.
On there.
So 855 is 0. Okay, so now I'm going to freeze. Not that, I want to keep that, get rid of that. All right, so now, what's my, you know the scale in here?
I thought it was 1-to-1.
It looks 1-to-1, that's what I'm thinking it is. Like I don't have any vertical grids, I don't know what's the grid interval there. This is northings and eastings. I normally would have a 0 and a -20, 40, 60, and a +20, you know, I'd have offset distance.
Yeah, they're 1-to-1.
Okay, all right, so we're 1-to-1. Now, and do we know what scale they're drawn at. Because I mean, it is 1-to-1, but is this like, is that a full? Oh yeah, that's a full lane width. That's like a 12-foot lane. So it's 1-to-1 actual. It's not scaled at all, right? Okay, so now with this, when you create sections from polylines on section grids, if you do it by layer, or let's say an individual selection, you read the little status bar and it tells you what at least one of them does. Selects a polyline that represents a section in cross-section view and then writes it to a section file. So that's the same thing as a section from screen entities. So that creates cross sections from a surface model. I think they've got that help system backwards. But anyway, if you do this from a section grid, if you say by layer, so I'm going to give this I'm just going to call it test. Test TR77. I'll say save. Now, the station text, all right, so it has, yeah, so there it is, 43 plus 0, 0. Must be drawn below or above the section line. Station must contain a plus mark. Sections must be drawn with grid lines. So there's my grid lines. And the grid lines must have offset and elevation labels. See, I don't have those. So that's what it's doing, is reading text. For if I had cross sections that were drawn typically like, let's see if and I'm guessing yours probably were maybe those are typical sections. Let me get to those sections. I realize you can't see these yet, but I'm dragging it. Let's do this. All right. So so you would have to have, there's my station value, my offset values, and I've got elevations on the breakpoints. Now I don't have them on all the breakpoints, but I don't know that I need every one of them. I think that's all I need, or maybe actually all I need are elevation labels on my grid. But anyway, if I have those things, close that. So if I have those elements, then I can tell it, okay, well, the layer that my section polyline is on would be, and I would pick, see, I picked that one. Okay, so yeah, that you would still have to get, you still have to make that a single layer, or change all of those top lines to be on the same layer. I was thinking you could pick a series of different layers, but apparently not. Let's see. Pick entity with layer to select, which I did the one. Yeah, see, it's only going to put the one in there. Now, if I.
But either way, if you had, say, if you draped your boundary polyline on there, you could have that layer, and that would take care of all this for you.
Yep, exactly right. But I don't know that that's doing anything any faster than doing what you're doing with that other command. So so this is basically reading the numbers and creating the cross section. Whereas when you're doing it with the drawn line immediately, you're creating these from screen entities. And we'll call that test. Here, 77 or whatever that was. Wait a minute. Oh, sorry. I have to, no, that I need an alignment file. Yeah, I think that is. Let's see, it'll be under roads. If you see it, yeah, I'm not. There's process sections. I don't think that's it. Oh, there's section menu. It's under a separate menu by itself. So if we create, there's a section from surface entity. So that creates cross section from surface model. Yeah, so he must be doing this one that the other guy you said was doing this. I bet he's doing the one I was just showing you
No, this is how we do it.
from a model, but you don't have a model. The stations for the sections and the left and right offsets are defined in the MXS file created before you run it. But if you don't have those offset distances labeled, yeah, see, in the surface model is defined by lines or polylines with elevation. The polylines could be a contour drawing. Yeah, see, that's looking for a 3D model file to read. Oh, surface entities, or you could do it from poly. This is drawing it from the grid. So that's what we were just looking at a minute ago. Sections from layers, cross section from surface entities. Now again, it's looking for elevation data, which you don't have. You're drawing it at 90 degrees rotated from that. Draw section. Yeah, I'm not finding that. Let me see here a minute. Construction roads, it'll probably just refer me. I'll set 3D vibrato sections from polylines on section grids by layer. That's what we were just looking at. There shows you some pictures that you have to have this. You have to have that as a particular layer, and you have to have these points with elevation labels, and you have to have offset labels. Yeah, I'm not sure that does it. So you're saying you use this create sections from design, no, from screen entities.
That's what I thought we did.
Well, screen entities is not the same as surface entities. So that's why I was looking at the wrong thing. So if I create sections from their surface entities, that's the one that needed the surface file. That's not what we want. We want screen entities. Maybe that's just, no, that's on the grid. And that's has to be 3D polylines. It's not it. Profile from layers, maybe. No, again, surfaces.
I would just keep doing what you're
needs,
doing, and I'll just start to have lunch and see what we do.
Yeah. So Yeah, I was trying to, it's probably, I mean, there's such a wealth of these options in here, and I don't. And the construction module only has those two. I've got offset by grade table, and that's the one that will work. So it's not documented, at least in this version. Yeah, find out. Because if we're doing,
I'll run and talk to him at lunch. Don't rack your brain
yeah.
now.
Oh, all right. Yeah, just let me know. So if you're doing that from those screen entities again, yeah, see, it still is going to ask you for that MXS file, and that's where it, that's a section alignment file is what that is. So it's going to have all of those settings set up. Anyway, yeah, find out, and we'll, we can talk through how that's done as a process. So hopefully though, this, this B poly kind of stuff will speed up this process for you pretty quickly. Yeah, and that's really the only way you can do those. Now, when you do that and you've got that 0, 0 trace line that you be polyed and you're using that for over here, you can do the same thing, but using the existing ground, right? So you can have, you'll have two different section files, and then now you can compute volumes, and it only does it, section to section. And again, it's interpolating in between. It's, you're an engineer, you've learned about average end area.
Yeah, much less accurate.
Yeah. So that's, that's the concept behind it, behind that average end area computation. But, and you could even, as this goes in and out, you've got some sections where they're partially in cut and partially in fill, and it'll accommodate that. So, that may be the only real approach you have, if the only thing you have to start with are basically the road drawings. You don't have a surface model or any way to create a true surface model, but you do have a bunch of these cross sections, so you can compare those. You can even pick up those materials and really, start working on those pretty nicely. So yeah, all right, so that's that approach. Now let's take a look at something here for a second. Drew, was it you that asked about boreholes in strata, or was that you, Josh?
No, that was me.
Okay, so that was Drew. When you said no, that was me. That was Drew speaking.
Yeah, Drew asked. I asked.
You guys have a bit of a similar sounding voice to me, and I rely on the little frame lighting up, and it hid behind another window on my screen. All right. So we'll do a real simple example so you can see how this works. We'll step through our little building single site project. Obviously, on these giant road corridor types of projects, we don't have time in the class to set all that data up to illustrate the point, but you'll get the point with all of this. And it is in that chapter 20. Remember I said you had to go to like page 760 to get to those tutorials. And it is, you look at the menu here, there's that CAD file takeoff start to finish. That's where we do the, make existing, make design. And then this road design with volumes, that's an actual typical road design. But again, you'll have an existing ground as a surface to design against. And but it accumulates materials in the cross-section depth. So when you build the template, you not only put the top surface, you can also put the subgrades and all of that in there. And then once all of those things are built and done and defined, those are the surfaces that you can then send out to your dozers, because the when you dig down to the depth that you're going to build your roadway, it is not necessarily always, 10 inches or whatever your cross section is under the main pavement. It's not that uniformly all the way under that top surface, because once you get off the pavement, you've got a different depth for what's under the curb, a different depth from what's under the little shoulder strip, and then a little sidewalk out the side. So all of those things will be much easier than having to, to do that, just dropping the surface 10 inches or raising it 4 inches or whatever you might be doing. These are the actual subgrade surfaces that you're going to be generating. All right. And then the other one will continue on with this, and it has that trenching example in there, which is a pretty nice little thing. It won't take us very long to get through it. And unfortunately for Josh, we don't have trenching in the construction module. That's a separate module that is included in the standalone takeoffs. That's another reason why it's $10,000 instead of 3,500 or whatever the difference is. It's still not 60,000. So, oh, sorry, I get the wrong one. This was, I had a prior customer sent me an email the other night that they had a problem when they were doing a sewer network, and they were putting laterals in that, and you see I'm on that same little site we were doing, but they were having trouble, like if they had to modify this main line, they weren't getting the laterals to stay connected. If this one, say, dropped 5 feet and the other end raised up 3 feet, these are just sort of hanging out there in space and they weren't going along for the ride. So I set this up and I did all kinds of variations on, you can tell it whether you want to hold this invert and swing the pipe like on a hinge, or keep the slope of the lateral and just raise it and lower it so that the depth of the clean out changes. Anyway, bottom line is I got every situation I could think of. Mine worked perfectly well. So I don't know what his issue is and haven't heard back from him, but that was a point and shoot that I missed clicking on because that was the last one I had. So if we go back to where we left off yesterday, and the file was demo 1. Now, if you did not save that file, that's fine. You can load it up again from the original data, but you will need to, set the boundary, which in this case, we've got this one that was pre-drawn. Now it's already tagged in the original file. And you'll need to set these layers, all of the index, enter. So index contours and intermediate contours, those become existing. And then design, whereas I doubt this TX07, that might just be a text label. But you've got pad, PR elev, that's proposed elevation, PRFC curb, that's proposed face of curb, and they're just elevation labels, and PRL CST, whatever that is, proposed LCST, no idea. The only thing left then, I've got proposed gutter flow. I think those two. Say that exit, that'll turn off my existing, turn off my other. And that leaves that's PR elevation, PR elevation, PR elevation, PR base of curb. face of curb. I don't see. Let's turn it back on. Let me take a quick peek here. I'm going to do a layer inspector. And just see what's up here. I'm going to isolate, make sure I say restore on exit. So yeah, that's just a text label there. Nothing on 0. Index contours, I've got 33. There they are. Index depressed, 1. Index labels. Contour. Intermediate depressed. Pad, my perimeter, that's my boundary. My PR elevation, and those are the ones I set them on to set the actual line work to 0 with the drawing cleanup. Not totally required. Now there's my proposed face of curb, proposed gutter. Yeah, 0 entities, so I don't need anything from that one. Proposed gutter flow line. The gutter flow line is the same as the face of curb. So I don't know why they have that. These are now there's PRL CST. Oh, that's that little landscape island. Straight text. We didn't. Yeah, so some of these layers have nothing on. Okay, so we're in good shape. I think that will define our layers. Under design, we did not need these 2 because they're empty, but they're there. So I'm going to just move them back to other. Move 2. All right, so now they're saved. Now, when we do our work, we built our boundary and we made our existing ground. So it's all within that. You see the shape of that, that's all within that boundary that we used. You can see, it's not a whole lot of space. I can see what's going on here though. You see how that's one giant from this point to this point. So it forced all the triangles over here. Do you remember what would have caused that and whether we might want to smooth that out a little bit? I mean, I wouldn't bother on this job, but if you did, if we go back to our Carlson configure under settings, take off site net, remember these, and it's this one right here to densify break lines. So now when I do it that way and say exit and just make this surface again, and let's view it. Same surface, but now look at the difference in the triangles. See, I still got an issue here. I'm forming all from here to here. But that's all right. Maybe I could put a break line in the data, say across there, but that wouldn't necessarily, I don't know that it's going to let me do it, but if I did, yeah, no, it's not. So, you could, if it were an issue, I think it's not an issue. It looks fairly uniformly changing. So I think we'll just let that go now. So that's basically where we left that off with yesterday. we are at break time, so I won't run you too far later than that. It's coming right up on 35, so we'll take 10 minutes. We'll come back at a quarter till and pick up from here. And when we start back up, you can let me know if anybody's got any problems getting back to this stage of this file. Let me know and I'll talk you through it real quickly. All right, any questions until we come back?
Nope.
Okay. Do my recording.
I'm here too.
Okay, there's Josh.
Present.
And there's Drew. Okay, now, so what we have done here so far is defined our existing ground just based on those contours up to this boundary. And again, we've already talked about philosophically, what I prefer to do is I would take this entire outer thing and make that my existing ground. And then that way I could tie these surfaces back to it. And we'll do that as a later step here in just a minute, later on in our process. But for now, we're going to step through basically what they're doing. So we've got some things. And again, all my line work now is red that is not elevated. So those are things I'm going to have to elevate. Now I'm going to turn off others so I get that boundary out of the way. And there's a couple of things I want you to turn off existing too. So this is my design condition, but look here. See that outline of my parking? It comes up to that edge where it, this is an entry exit into my parking lot, but it's open here. So that will cause our processing to fail if I give this depth, which I'm going to do. So I need to close that polyline. And I could either just, draw a segment, add it to it, or just simply select it and come over here to my properties and choose yes, closed. And for whatever reason, oh, it made it an arc because that was an arc. I'll just hover that grip and convert to line. Like so. Okay, so we need to make sure that's closed. And we need to do the same thing for these. So just double check, make sure they're all closed. There's my building pad now, it's closed. My landscape island or hardscape, whatever it is, it's closed. My island up front, yeah, so they're all closed. So they're going to be good, but they need elevation. Now the parking lot, you can see, has all kinds of elevations here, but I've also only got one line and I've got two elevations. I've got a top of curb and I've got whatever FS stands for. FL would typically stand for flow line. So that would be the face of curb. FS, I have no idea. Maybe they mean face of sidewalk, but you can tell from the differential, it's half a foot lower. So that's going to be that's a typical curb drop off. Now, a couple things that we could do when we do this. And here's one thing I want you to do too. I just spotted something that's going to cause us a little bit of an error if we don't fix it. Right up here in this corner where we were just looking, zoom in there and I want you to, oh, okay. I thought that line was broken. It's not, it is, it's just a line type that showed the gap pattern. So I'm going to right click that or select it, right click and select similar. And I'm going to come over here and I'm going to change the line type to just be continuous. Okay, so those are my labels. And I made them all continuous so I don't see that problem. I thought they had a gap in it and it wouldn't connect, but that's good. Now, so we got two approaches on this because this we could set this line as being the face of curb, and then we could offset with a 3D offset just a little bit to keep from being vertical. and make it half a foot higher all the way around. Now that works for most places, except for things like right in here, where you see, now this is a half a foot, that's half a foot. You know, right here, 35 to 37, that's only 200ths. So there's a little bit of, I think that's going to be, you know, it pulls that top of curb down to basically meet the face of curb. So it's like a access ramp or something into that area. So we've got a couple of those places. Here's 41 to 43. So it comes down, it's really not all that well defined, because it comes from full height here, drops down to almost nothing here, and then climbs back to full height here. So it really comes down to a point and comes back up to a point. They're really, you know, this ought to be this same type of differential. But in any case, since that is labeled as it is, we'll take these values as they are and see what it gives us. It's probably not an ideal design. Here is, let me see, here's another one, just 200s right here, but the full height here, 200s here. So this slopes down from here, comes to meet the pavement, then climbs right back up to full height here. So, you know, you can see if you were to build that, they would laugh at you. So, so we're not going to build it. But so what we're going to do is, instead of just blindly offsetting that to be half a foot higher, when we do our offset, we're going to do a 3D offset just a little bit back, bring it back vertically, or maybe we'll treat this as the top of curb. We'll read all these top of curbs, we'll drop it down, and then we're going to go through and let it read this bottom set of numbers to set the outside one, which will be our face of curb. So we're going to treat this line and this line as our top. We'll elevate it, we'll set the back of curb behind it, and we'll set the face of curb down in front of it. The one we set back behind it will be the same height all the way around, but half a foot away. And the part we put down here will be only half a tenth away, 500ths away, but half a foot lower. And then we're going to go back and let it pick up those odd little spots. No, we've got that backwards. Yeah, anyway, we'll do it correctly when we do it. We're going to read, let's see, if I read the top, top of curb, that one's not done. Let me find that one that's done this way. So it's the top of curb that comes down to this elevation. So yeah, we'll just need to go around and edit those particular points. We'll go ahead and elevate this to the top of curb. We'll do our offsets. We'll do the front offset here. Here's what we'll do. All right, now we got it. So what we'll do is, let's offset this 2D polyline. Keep it 2D, and we'll offset it out to be the face of curb. And then we're going to elevate this top line to these text numbers, and and the bottom line will elevate to these bottom numbers. So that will have the effect of pulling this line down to meet here, but then bringing it back up on those. All right, so that will be our strategy. Okay. So let's first of all do our offset for the actual face of curve. This is going to be our top of curve line. So we're going to offset that just with a standard offset because it's a 2D polyline, and we're going to just put it 1/2 tenth away. Okay, so it's near vertical, but it can't be entirely vertical. It has to lean back a little bit because of the way the triangulation works. So I'm going to select that line, and now I'm going to pick out into the parking lot area side, into the pavement. So I'm going to do something like that. Okay. And so now when we go through and elevate these, we'll elevate this line, the inside top of, we'll elevate to these pieces of text, and we'll elevate this line to these pieces of text. Okay. I follow that. Okay. And then once we have this line elevated, now the reason we're not going to offset this back of curve yet is because these lines don't go and touch it. So I can't do that same trick to elevate that line. But if I elevate this one first, I know I want this back offset to be the same elevation all the way around, but just 1/2 foot away. And for that, we have to use a 3D offset. So here we go. The first one we're going to elevate will be the top of curb, and we're going to do those with those TC labels. All right. So this is going to be on our elevate menu. Now, Drew, do you have? Yeah, you got the same elevate menu. All right. All right. So let's go to the elevate menu. We're going to turn a 2D into a 3D, and we're going to do it by text with a leader. Okay, so when we do that, now the command line gives us 2 choices, options or asking us to pick things. So let's look at the options first. So if we say O for options, it says enter a maximum distance between the leader, so from where the leader goes and where the polyline goes. I can give it a tolerance, and it's a multiple of the text height. So if I could miss that line by the height of that text and it would still read it. So I don't need it quite that, it won't hurt it, but I'll just put it down to 0.1. All right. So now it's asking me to select a sample of the elevation text. So when I choose that, I'm going to pick that right there. Now, that has picked the layer that text is on, and I think all of the text labels are on there. So you're going to see how we strip it out to the different labels. Now, we're stepping through this. Are you guys familiar with this stuff already? I mean, I don't want to spend too much effort, but if not, this is something handy to know.
I've done this before, yeah.
You have. All right, Josh, how are you on this?
I'm all set with this.
Okay, I mean, so, all right, so let's just go ahead. We'll go through it pretty quickly now. Then a sample of the leader, we'll pick that one. And now a sample of a polyline to convert. Now select the polylines to convert the leaders and the elevation labels to process. Now I'm just going to type all because I've got these on the same layer, but now that I've selected everything, I'm going to unselect. So I'm going to type R to remove, and I'm going to get all of those inside lines. So that's got Oh crap, sorry. We haven't offset this one yet. All right, again, put that back to there. And let me offset all of these lines, same distance here to there now. All right, so I've got those two, not that, but this one. So I'll offset again, same distance here to here, and I'll do this one here to here. All right, so now I've got everything done. Now we'll go back to our elevate by text with leader. Again, we'll give.
Thank you.
Yeah, go ahead. Oh, I'm sorry. I thought you were asking a question. So there was our text. There's our leader and a sample, the line. And now select everything we want to work on. I'm going to say all. And before I finish, I'm going to say R to remove. I'm going to remove all of the interior or the parking lot side lines. I don't want to elevate them yet. So moving down, make sure I've got that all the way around. Yep. And I've got this one up here now to do. Okay, that should do it. Now, when it comes up, after it knows what to work on, it says, now do I want to enter an elevation to add to the label values? Now you notice the labels are all just 17 point, and my building pad here says 17 point, but it's 818. So they've just dropped the 8. So I'm going to type 800 as a value to add. Now it's going to run through all these labels and it finds all of these different pieces of text on that layer. So which ones do we want to use? Well, we're elevating the top of curb right now, so we'll add that one over here. Now you could also have put in a vertical offset for that one if we wanted to raise it beyond, but we're not. We're going to take those. We could have put the 800 in here either way. So now I've got this and selected, and I'll say okay. And so it's going to run through and now elevating all of those outside lines. And if I look at this vertex, it should be 816.27. I look down here at my coordinates and my status bar and I see 816.27. So that part's good. Let's go over and look at this place where it's stepped down. So in here was 35 to 37. So that point right there is 817.37. And then it comes all the way back up here to full height at 1806, 1806. So that all went fine fashion. Okay, it's turned back to its original color because it has now been elevated. So we're going to do the same command. Elevate, FL by text with a leader. And we're going to go, just repeat the process. We'll pick a sample text, we'll pick a sample leader, and we'll pick a sample line. And now we're going to, again, select all. And before we finish, we'll type R to remove all of the green ones that are already elevated. And then I've got one more out here. Make sure this one is not selected. Okay, that's good. And we'll say go. And we're going to add 800. It's going to process. Now it's going to find these. So I've got flow line. I know I want those. FS, whatever that stood for. We'll also want those. Okay, and then we should be good to go with that. We'll say okay, and off it's going to go. And now it's elevated everything. And when we look at that in our 3D viewer, right in there is where you can see that. See how it drops that down? There's a point where it does it. There's a couple of other spots right in here. Okay, so it's now set to all of those spot elevations, right or wrong. I don't think it's very good design, but anyway, that's.
But did it find all those points by itself, or was that you clicking each one?
Did it find these points to drop down, you mean?
Yeah,
Yeah,
based on the text.
yeah, because when I told it, the first time I ran it, let's look at this and whoops. Hit myself here. I see a little thing right in here we're going to fix in a minute. But anyway, when we told it to elevate this line, this top of curve, and then of all the different text that we saw, we only used the TC labels, so it ignored the FS labels. And so when it comes down here, that TC was only 2/10 or 200 or whatever that was above the FL label. So that's what caused it to come down here. So it found all those points where those leaders came in and hit that line. Okay. And then when we did this line, the actual face of curve that we offset, we gave it a different set of labels. We used the FS labels to set that. And that's what, you know, this is more of just a consistent around here. This pulls this down and it pulls this down to that based on that TC label. And yes, it found all of those as it went. Now we do have a problem right in, we're gonna use the right icon here, that we'll need to fix. Okay, so we'll fix that here in just a second. And not real sure why it would have done that, but let me take a look at something here. These are all 5/10 away. So that's consistently 5/10 away. So my quickest fix is going to be not to try to get rid of this and figure out where the arc goes. I'm just going to erase it entirely. And that's the outside edge. So if I erase that, and I'm going to offset this down to the pavement 1/2 foot, but because it's a 3D structure, it's got changing elevation. I can't use a standard offset. If I try to do that, you know, AutoCAD's going to complain. If I pick this, you see, well, wait a minute, take that distance. If I pick this, see, it won't let me do it. It says unable to use the selected entity, but it needs to be all planar. So we're going to go to our edit menu, 3D polyline utilities, and we're going to offset a 3D polyline. We've got a bunch of different options. The one we're going to do is interval because it's going to ask us how far horizontally and how far vertically. So I'll say okay. And once into the horizontal offset amount, that's where I'm going to type in 0.05, 1/10. That's how much horizontally, and how much vertically. I'm going to say negative 0.5. So drop it 1/2 foot. I would enter. I'll select this, and then I'm going to go out to the pavement side and set. Oh, why is it unable to offset? It's closed. One more time, maybe something wrong. All right, so offset 0.05, negative 0.5. Select a plane, offset this one. Which side? Oh, that may be why it caused the problem. All right, so I suspect what is causing that is, I'm going to draw the start and end of this polyline. Yeah, see, it starts right there on that start of that arc. That may be what's causing it. So I'm going to change where it starts and ends. I can get rid of that little marker and see if that's going to fix it for us. So I'm going to go to, let's see here, if I see, edit polyline, set the polyline origin. If I select this polyline, and we'll select the midpoint here as my origin point. All right, so now that's where that one starts instead of out here on the PC. Let's see if that'll let us do our 3D offset. 105, negative 0.5 here to here. There we go. That fixed it. Okay. So sometimes you just got to look at the, what's happening geometrically and try to figure out, mathematically what might have caused that. And it was because it started here in whichever direction it's going, and it closed back on itself, and it's trying to assign elevations to all of these little resulting line segments you see from that original drawn 2D polyline. The one thing that we could have done is we could have copied that polyline, the original 2D polyline, and put it on a separate layer so that if we had to go back and dimension this drawing, we could read the radius of these arcs. Now they're no longer arcs, they're these little segmented approximations. But we're not building the finished drawing, so we didn't need to worry about doing that. We're building, we're building a model. We're not, we've already got the finished drawing. So we now have our face of curve taken care of. We'll next offset our back of curve. And we're going to do that for all of these lines, again, with my 3D, offset 3D polyline, same method, interval, but this time the horizontal distance is going to be half a foot. So we're going to do 0.5. And the vertical difference is going to be 0. And we're going to go here now, take all of the inside, that's my top of curves, and we'll set back here. So that was the island. We're going to need to grab the outside of this and go that way. And the same thing here. Here and go that way. And we got one more island up here to do. Here and go that way. Okay. Have everything like I like it. And again, I'm a big proponent of looking at this stuff to make sure there's no gotchas that you're not aware of, that you can't see. We'll look at these little depressed curb areas. And there you can see what that does. Now again, I think they probably should have had another point over here, so it brought it down and then had a, a smooth, flat spot. And we could go and fix that if we wanted, but For our purposes, we'll leave it alone. And, you know, that's exactly what I would have done is I would have changed, see how this is 200ths? I would have made this difference 200ths also, so that this is the depressed area. And it goes from here back to full height, and it goes from here back to full height. That's the way I would have normally done that. But you get the idea, and you've seen how to elevate these based on all those spot elevations. So that part's good. We now need to simply elevate our two remaining pads, and you can do that simply by selecting it. We know that's 817.56, so we'll come over here and put this 817.56. Okay, now it's still red because we used a CAD command to elevate and not one of the Carlson commands. So I could go to my takeoff menu and say update colors for set elevation, and there it is. And it looks like, oh no, that's just a different color. I thought it was supposed to be green. It looked like there were two things. Now, another option, let's say you, and we've only got one building, so that's fine. But if you had a subdivision with all kinds of like house footprints or building footprints, and they all had finished floor labels inside them, you can elevate your building pads by 2D to 3D by text. I think there's one, let's see, looking for interior text. Oh, pad polyline by interior text. That's what I'm looking for right there. So a pad polyline by interior text, and you can set the layer for the elevated lines if you want to. I'm not going to. I'm not going to keep the original. You could also have it trim any kind of elevated contours inside. So if you had drawn contours, they could trim them out. There's nothing there, it won't matter. Do I want to offset the elevated polyline? I'm not going to, but that lets you do a little like a half a foot layback if you're doing a curb. So that's good. Now I don't need to put a 800 adder here because this already has the 800. Now, even though it has the word pad in it, it's still only going to read the numbers out of that. So I'm going to say, okay. So a layer sample of the text here and a layer sample of the boundary line work here. Now, and it lets you do multiple layers of different line work, but I'm done with telling it which layers. I hit enter, and now I say select so select a layer sample of the outside elevated polylines. I don't have any. That was where it said trim those elevated lines that cross it, so I just said enter for nothing. And now select the entities that I want to process. In this case, it's only these two. Again, if I had a subdivision, I would select them all, and then it would go through and read everything. And based on that 1870, you see over here, it has created that, moved it up to that elevation. So using a Carlson tool, the color updated automatically. When we just set it by properties over here, we had to update our colors, but now we're good. We look at everything here. Again, just to make sure that we don't have any spikes or gotchas, and we see that we've got our building, our curbs, everything's good to go. Now, I can tell you right now, and we're not going to go to this effort to fix it, but all along this polyline, you're going to get triangles that are going to try to sneak out of here and touch down into here. So you're going to get some little kind of weird convolutions in here because of these little insets. Normally I would draw a building, an enclosed pad that's more rectangular to take into effect the whole building and set that to that same elevation. And you could even do that by just drawing a polyline, click, 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 and putting it around there instead of, but we'll let this go. So it's going to do that linear difference in between all of these areas in here, and that's fine. We'll let it behave that way. All right, so now we've got everything elevated. Let's go back now and look at setting our subgrade depths. So we do that on our define layer surface material subgrade toolbar button, or on the takeoff menu, define layer surface material subgrades. And we look at our design tab, and here we've got the pad, which will be the building, and this pad here. And we've got, these are our text labels. There was nothing on that layer. So it's really just this pad, which will be both of these, and this proposed curb. So that will be our parking lot that we're going to do. Okay, so in our pad, if you select it and hit edit layer or just double click it, it's going to bring up this guy. Now, what I would do in this case really is that, you know, this building probably has a different subgrade to it than this little hardscape pad out here, but for now they're going to both have the same. And we'll just call that pads, call it whatever you want, you know, buildings or whatever. We'll include it in their material quantities report, and let's set a color for our 3D drive. We'll make those, say this, you know, some kind of a blue, so you can see it when we look at the 3D drive view. And again, you could give a material cost if we know what they are. I know where, you know, I have no clue. I don't know if you pay $5 a yard for concrete or $500 a yard, you know, or for stone by the ton. But if you know those values, you know, you would put them in so that you can get the costs. Now, we want to turn on that we will adjust the target surface by the depth. So whatever depth it is, that's going to drop that subgrade. That's going to give us that file name dash FE. No, that's the existing file name dash. We got the base and then the file name dash F. And anyway, it's one of those that took care of the subgrade adjustment. That's what we're, that's the surface that will be adjusted by the depth. And our depth units right over here in the slide, and it's really easy to overlook this fact. So when you put the depth in here, it's expecting feet. So we want to make sure we put that in as inches. And then if you say use vertical from pad to surface, that means it's going to do an actual vertical drop here, even though you can't model a surface with vertical edges. It creates little interior boundaries that are vertical, so it cuts off any little differential that it's going to do there. So that's if you choose to do it that way. And it works that way by default anyway, if we don't check that. This use layback, and you would give it a slope. That's for things like if you have, say, building pad, building footprints, but they're basements. And when you excavate down to that basement, if you want to make sure, you know, for safety reasons, you always are going to have a, you know, a one-to-one layback on those excavated holes, or, you know, a 1-to-5, or, you know, whatever that you choose, you would have it set that subgrade base down to the bottom of it, and then when it climbs up to meet the final surface, it lays it back, whatever that ratio is, because that's the amount of material you're actually going to be cutting out to get to the subgrade. All right, you follow that discussion? Okay. And so for ours, we'll just leave it unchecked. We'll just let it go vertically. So let's start adding in our subgrade. So the first thing we want to do is call it, we'll add concrete. And what's a typical pad under a building? I don't know, 8 inches, 12 inches, 10, anybody?
Typically 8 for us.
All right, let's go with 8. And we do have our units set to inches, shrinkage and factor. Now, how much do you pay for concrete? Has anybody got an idea?
$100 a yard.
All right, so we're going to say 100. And we're going to say per cubic yard right there. Okay. And we could, again, if we have stone and we're going to put we're just going to put stone underneath it. We'll just call it stone. And what do we typically do there? Depth.
4.
Stone. Do we know a cost per ton or anything like that?
$9, $10 is fine.
Let's say $10, and that's per ton.
Yes.
All right, so if we're going to use tons, then we have to set our density, and if we're using 25 pounds per cubic foot. This set button, by the way, you see, I don't have anything here yet, but you can define a material library, and you can, keep that for all your jobs, and you can have different densities for different materials if you did a lot of that reporting. So that's what that button's for. All right, so that's probably all we need for that one. We'll say okay. We've got the concrete, we've got the stone. Now let's go to our parking lot, which is this FC curb. And the material name here is going to be parking lot. And we'll make that color. We'll set that to be, say, one of these grays like that, 253. And let's see. Now we could have just used that one line without offsetting those 3D edges, the face of curb, top of curb, and back of curb. We could have just used one and then said that it was a back of curb type of pavement. And then we would put in so if we did that, then we put in these curb dimensions, we would actually define the curb dimensions. But the reason we didn't do that is because we had those little drop down areas. So we have some depressed curbs in there. But if you ever have something that's just ringed by curb, that might be the easiest to do, and you only need to define the one line. All right, so now, again, switching to inches as our units. And let's call this one, what do you typically call your top surface of asphalt? Just like WC is what we use in Pennsylvania for wearing course.
We just call it surface.
Yeah, surface course, wearing course is fine.
All right, we'll call it surface course. And yeah, we'll go with that. And that's what, 1.5 inches? What typically?
1.5 inches usually.
Yeah. Do we have a cost? Anybody? Or do you just make one up?
Just put 80 or something.
80, and that's per.
Well, that's per. It's measured in tons. Yeah.
All right, so measured in tons. I have no idea what the density of asphalt is. It's probably a little less than.
It's 2 per yard, so 8 per cubic foot.
So it's 2
tons per yard.
2 tons per cubic yard. So dividing 4,000 by 27. Is that right? Let's see, 4,027. That's $148 a ton. Oh, wait a minute. You said it's 2. Wait a minute. What did you say it was? It's 2
tons per cubic yard.
2 tons per cubic yard. Wait a second.
145 pounds per cubic foot.
Yeah. Yeah, I got 148.15, so we'll call it 145 pounds per cubic foot. Okay, so that's our surface course, our base course. again, of asphalt, what's that typically? 2, 4?
4.
4 inches there. We'll just call it the same. I realize it's probably different. And then we're going to call an aggregate. And that's going to be stone under that, or, you know, whatever sub base we have. Give me an idea, what, 4, 6, 8, something?
6.
So 6 inches there. And we said that was a cost of
$10 per ton usually.
$10.
So we go back and look now, see, we're starting to build that library. So we look at our stone was $10 a ton at 125. So we'll say aggregate will be $10 per ton at a. All right. So we say, okay, we've now defined everything within that. Now, so what's going to happen? Go ahead and hit save and exit. So what's going to happen when we build this surface? It's going to build all 3 of those, you know, with the aggregate, and if, excuse me, and then if we had any topsoil stripping and replacement, we would see those as well. But it's going to be, because it takes that outermost edge there and goes to the inside till it hits this other target and stops. And so it doesn't put the base under this here because I'm closed off with that. And then from here, because this went around this way, it tries to make that whole thing, well, it tried to make this whole thing asphalt, but it comes out until it hits these edges. It hits here and it stops. It won't go inside, but it comes out here, but it hits this edge and stops. So it won't continue on in here. Same thing for this building pad. It's going to dig underneath it, and it's going to, well, there's nothing inside of it. So it stops on the edges of that. But if there were, say, a courtyard in here as a closed polyline, it would not put the sub base underneath that part. It works just like hatching works. Okay. And in fact, you can look at our subgrade areas, and let's hatch the subgrade areas, and let's hatch, say, for the parking lot. And we just take the default, oops, 1 unclosed polyline for a face of curb. All right, looks like it took it. Okay. So it's going to go, you know, all the way edge to edge like that. But it stops, you see at the islands, and it stops here before it goes on inside. If we do the same thing, we'll do the pads now, and we'll change it to a different color. And what layer is this on? Ah, that's our PRL-CST. Ah, so it is separated. So there we go. It's a good thing we did that. We'll go back to our layers, and that's just our little hardscape area. And that was on design, PRL-CST. So let's give that one. We're going to call this one papers. And let's just, we'll set it to inches. And we're going to make that a 2-inch, oops, sorry, a 2-inch thick paver. Yeah, let's just call it $15 square yard. We'll do it by area. You get a paver for that square yard too. That'd be more than $15. Let's call it $40 per square yard. And then underneath that, we're just going to put sand, and we'll put say 4 inches of sand. Anybody know what sand costs? $5 a ton. I have no idea what sand weighs. We'll call it 110 pounds per cubic foot. All right, so now we save, exit. And we could go back and let's hatch now for the pavers and get that. So now we're all good to go. And you could say, you know, if you wanted to define these areas, if you had some kind of difference in there, it would take care of those as well. All right, so we've verified everything. We'll go to our subgrade areas, and I'm going to erase those subgrade hatches because I don't need them hogging up my drawing right now. And now we're good to go. We have, if we look at our checklist, we've done our boundary. We've defined our layers, our existing ground. It says it needs update, but we haven't made our design. We've actually made it. It would work without doing it, but it doesn't hurt. We'll just rebuild it. We'll make existing. We'll make design. So now we've got a problem in here. It's going to jump to these unclosed. There's an unclosed polygon somewhere. All right. So I've got 4 crossing break lines. Ooh, I've got a problem right in there. Let's see if we can find, aha. There we go. So let's fix that. That's what happened when we did that offset. Now this is part of that original curve line. That's where we had some messed up geometry in here. All right, so let's take a real simple approach. I'm going to remove polyline segments. So I'll find that little button right there, and I'm going to just remove each of those. And I'm going to remove those and then erase the leftovers. Now, I'm going to draw a 3D polyline. I'm not going to prompt for elevation. I'm going to turn that off so that, and I'm going to uncheck this use. Well, it won't matter what I'm doing there, but I'm going to not prompt. So I'm going to read the elevation when I click on that endpoint. So I'm going to say C to continue. So it knows to pick up where that one left off. So I grab that endpoint and you see it read the elevation. That's showing me down here on my status line. So I'm going to come up here and I'm going to close it off to say this guy right there. And hit enter to finish. And now when I select this, it is closed, but it says it's not mathematically closed. So I'm just going to change it to yes. All right, so now that part's closed. And to tie off the rest of this, let's see what I want to do. I think I want to do it this other way. I'll draw another 3D polyline, C to continue, and grab this back line. And then grab this line. Include. And actually, one more run at this and get rid of both of these. I'm going to connect that. I'm not going to continue. That's my problem. I'm going to pick so that I get on that same layer. And now I'm going to say go from here to here. Now that is my back of curb. I'm going to now offset that with my 3D offset command. My 3D polyline, offset 3D polyline by interval. I'm going to go half a foot horizontally, 0 vertically. I'm going to come toward the inside. Now I'm going to drop that one down and just barely inside. So I'll repeat the 3D offset, same method, but this time different numbers. So I'm going to go half a tenth, and I'm going to drop it by 5 tenths. Take that one, go to that one. Now I've got this curb structure and this curb structure, and these are already connected. I'm just going to trim these off where they meet and tie in these elevations so that they're exactly the same elevation. So I'll just select this one, the next one in, and this one, and I'm going to say right click trim, and I'll trim off the ends. And I'm going to select this one, and that continues all around there. I'll right click and trim off those ends. And now I'll resolve these. I will select those, right click, trim, and trim that one and that one. Now remember, what it's doing when I do that is that one, that as well. So when it trims, it's just doing it in plan view, looking down on it. If I were to look at that structure in 3D, it's going to probably not be exactly same elevation. It might be. Yeah, see how they don't quite meet? So I'm going to make sure that I tie those things together correctly. And I just didn't select those other points. So I got myself oriented here in 3D so I can see the relationship there. I'm going to go to my settings tab, and I'm going to choose this button to set my CAD view to match that current view. It tells me that's now set. When I exit, I'm now at that orientation. Right down here's where I want to be, and I'm just going to grip edit this line. I'll snap it to that endpoint. That one's already there. This one's going to snap to that one. I think I'm doing those in the right places. Grip edit here to here. Something, yeah, a little bit of left over. And the same thing here, I'll grip edit this and snap it up to that. All right, so now plan view. And now everything should work. Let's make sure these are all closed. That is not closed. Oh, it's not closed because they're individual segments. So I'm going to join nearest. Just a tenth is fine. I'm going to say just directly connect the endpoints, but they're already connected. Join only identical elevation. So that will also check the elevation. So I'm going to check this one, and this one. And that should all join. And now when I select it, I see that it is closed. So I'll now repeat my join nearest, Say okay, I'm going to select this one, that one, and that also connected there. Select it, make sure it is closed. Indeed it is. I'll repeat one more time. I'm going to get this guy and that guy and make sure it's over here. It joined, I selected, yes, they're all closed. Everything is now good to go. Might not be a bad idea to hit save. And I'll now go back and make my design surface again. And looks like we had good success. So I'm going to go and view that as my surface. I will look at my surface file viewer, and that is going to be that I've got the base surface, that's that BS. And there you can see where the pad's going to be, and you can see how that, see, we probably should use some additional break line information in there, because that's going to come up here and drop it down. So that curb's really high right in there. So that curb design is not really well done. So I need some additional break line information in some of that, but you know, it is what it is. We're not going to fix their design right now. Now notice this part out here. Where did those triangles come from, if you recall? Everybody remember when we said under our settings, Carlson configure, takeoff settings, we said to extrapolate the to the boundary perimeter. And if we look at our boundary perimeter, which is an other, that's where it is. So we told it to go ahead and extrapolate out to there. If we do not, we turn that off. We won't extrapolate out there. We'll say okay and exit. Let's go back and rebuild our design. And now we view that surface. Still did it. Did I miss? It only applied the subgrades on the inside of it, so that part's good, except for there. That worked okay. See my settings. Extrapolate surface to the boundary. Well, one way that you could get around it is this, is go back and set the boundary polyline now. Clear the existing yes, and we'll select that back edge as our boundary. Now, let's build our design. Look at that surface again. And now you can see it stops right at that bounded edge. Okay. Now, keeping in mind, that doesn't, you know, we haven't tied those edges back down to the original ground, which is really what we should be doing. Because there's going to be a little bit of fill or cut, depending on how that sits on that existing ground. And if we look at it, I'm gonna go to my model tab and I'm gonna add a surface and I'm gonna put that original ground under it. And there's a little bit of glitch here. I go to view control, I'll uncolor the triangles and then color them back. Go back here and turn off my triangles. And so now you can see the difference in the existing ground that's underneath. Turn these contours off too. So you see now I've got, well, the existing ground here is above. Down here is my design surface and it's underneath that existing ground. So I've got quite a bit. If I build this curb surface to get back to that existing ground, I'm going to have to, you know, put a little cut slope in there and it's going to be, you know, back in here somewhere. So that's what I would do were I building this. Now here's a case where like over here, we're up above, we're not too far up above, but it's just going to put those little, you know, it's going to put a little vertical edge there. So if I tie that back to existing ground, that's, you know, that would smooth out these things here. Now, we're not going to take the time right now to finesse that, but that would be some of the changes that I would make. Let me turn off this. So I would fix that, and I would fix that bit right there. You see how that is way up in the air, you know, and now we did it according to the plans, but we would look at that and say, well, maybe that's not supposed to be like that. Maybe we should smoothly transition along those lines. And the way we could fix that is to simply remove that point as a control point. In fact, let's do that part right quick. So I'm going to go out here. I'm going to turn my other off to get that boundary off. And these are the lines that have that little hitch in it. So if I go to my elevate menu and I choose my polyline elevation editor, I'll pick the back of curb first. And I'm going to be interested in here from point 372. Spot. Yeah, that's my high point. So 372 is set as a point of elevation here, that, and it read that elevation from the label, remember that was there. So if I take that point 372, if I could get my mouse to select it, zoom in a little bit. So now I've got the 372, and notice it's checked because it's a control point. If I uncheck it, that's going to interpolate from this last point back here all the way around to this next point down here smoothly. Okay, so I'm going to, that will be good for that one. I'm going to choose this instead of saying okay and then run the command again. I'm just going to choose this to pick another polyline. I'm going to pick the next line down, and I'm going to select that point if I can get to it. 194. I'm going to uncheck it. I've now relaxed it. I'm going to choose this next one right here, and I'll select that point, 386. And 386 is unchecked, 385 is unchecked, so they're both interpolated. And now I'll say, okay. Now I'm going to view that corner, my 3D viewer, just to make sure I haven't messed anything up terribly. And I look at that and I see, yeah, that's a little bit more like what I wanted, and it doesn't have that giant peak in there because this elevation was bad. So now I'm going to make my design surface again. And I'll go back and view that. And it's still got a high point in there. I didn't see any points when I edited it though. September. I'll just take those points out. Let me see if I choose that and remove point. I don't know if it's going to work. No, it's going to. All right, let's see what else we can do with this. It's clearly putting a point right in here in the surface, but if I look at that in 3D, it's not in the line work. That's probably something to do with the origin of those lines again. Let's do make it it's somewhere else entirely. I'd see a little red circle if it were right in there somewhere. It's not caused by that. Let's see where it is. There's a little red circle on my drawing somewhere. Well, all right. Instead of trying to chase down a ghost and all this, that would be an issue. And if I were to build this as a surface, let's just do a triangulating contour. I'll show you what I mean. I'll write the file and I'll just call it FG for future grade. And I'll use inclusion exclusions. Will not contour. I have no filters. Okay, good. Say, okay, I'm going to pick the inclusion boundary. Exclusion boundaries, I'll turn it off. At the island. The pads. I don't think any of these things are elevated, but just to be on the safe side, I'll just select the line work. Select, all right. So now when I look at that surface called FG, that one will have gotten rid of that little high point right in there, you see. So it reads that correctly when you do a standard triangulation. And there's something about the nature of that, the takeoff process that reads it from those layers. Now, right in here, you see there's that little depressed curve that drops down to that point. Okay, so, you know, in reality, you would have that fixed up a little better. Maybe densify this a little more so that they all don't tie back to that point. They've got something to tie to here. So yeah, our normal triangulation gets the surface correctly, but that doesn't help us in the sense that we don't have the subgrade depths. If we were to switch it and use that built surface. So anyway, that would be something I might run past tech support at Carlson to see if they can give us any insights into that or tell us that that's a problem. If I get a chance, I'll run that up their flagpole. So we'll leave with that little glitch for right now. And so we made our existing, we've made our design, everything's done. All we need to do is calculate our total volumes, which is right here, the next step. Standard viewer, report tons, cut and fill depth zones if we want, and we'll say okay. And here we have, we've got 6,500 yards or 88 tons of cut, 1,400 yards of fill. You get the idea. Now here's a number. You construction people probably understand this when you're working, when you're doing some planning for big sites. It goes right in here and it creates little equivalent cubes. It tells you how much area you have in cut, how much you have in fill, and it uses those and this bit down here, the average cut depth, average fill depth, and it comes up with using this area as a square and the depth as the vertical part, and it creates a cube of cut, a cube of fill, and it comes up with these numbers and it says, okay, this is how much you'd have to change. You'd have to raise your final grade by 1.2 feet to make the site balance. Now, I didn't put any shrink and swell and all that kind of stuff, and it's really fairly closely balanced. But right here is the number that contractors usually have in their hip pocket at the negotiating table. They know that for every 1/10 of a foot, how many yards it's going to cost if I raise it or lower it. I mean, that's how many yards of material is in that equivalent cube of material in my project. So as an example of using that number, I was doing a job up in Owego, New York for Lockheed Martin. They were designing they were putting in a new hangar to work on the president's helicopter. And so they had this, and the architect, we had it all laid out and all the earthwork calculated and everything all set up on the site. And it was a pretty huge building. And the architect said, yeah, but when you're driving up the approach road and we look at it, it sort of sits down like it's tucked into the ground a little bit. Can we raise it up like 2.5 feet? And because he wanted his design to be front and center. And the contractor said, the earthwork guy, he goes, sure, that's 2.5, or that'll be $4 million. And the architect just about had a heart attack. He goes, what do you mean? And he knew this number. He knew how many yards every 1/10 of a foot would be involved in changing the height. So 2.5 feet is 25 tenths of a foot. And he knew this number here. So he could calculate what 25 times that would be, or just multiply it by 100 and take 1/4 of it, whatever. And he knows his cost on hauling material, per yard, or however he came up with that number. But he just did a real quick back of the envelope calculation and told him that cost. And so the architect got a lesson in vanity, because he thinks, well, gosh, you're just raising a building 2.5 feet. No, you're raising a site by 2.5 feet because everything has to tie together. So that's what those numbers will do. Now, that was the quantity report. And we have another one. And yes, I'm aware we're a little bit over lunch break, but you'll get your full hour here. Just another real quick run through. Those were our total volumes. We have materials quantities, and we look at that as a standard report, and we'll take the entire drawing and we can do it by material with subtotals, report tonnage and report cost, and say, okay. So now here's our materials. I've got this much aggregate. So 2,000 tons of aggregate. It's going to cost me $20,000. My base course for my parking lot is going to be $125,000. The concrete that's in my pad and my, I guess just my building pad, 55,000. There's my pavers, 14,000 for that little hardscape area. Wasn't much cost on the sand, but remember, I put in a pretty stupid number. I would say $5 a square yard or something. I don't remember what we did it by the ton. Anyway, you get the idea now. And there's my surface course of my asphalt as well. And then totals up all my different values for a total cost of $250,000. Now, whether that's any good or not is dependent on how accurately I costed out my materials. All right. So those are some of those that you can do. We can also do a cost summary report. Let's see what that looks like. We'll just take them all. So yeah, we would set up a dollar amount per yard to move material, and that would come up with our total cost. And we're just saying $1 a yard. I had no idea what that's how that plays out in terms of reality. But anyway, that's sort of what you can do once you've defined those sub-base areas. And you also have, and we just looked at that top surface, but let's look at our That was our base. If we look at our final, oops, I'm in the wrong file. This is called demo 1. So demo 1Z, and this is their final zones. And there you can see, if I turn this off a little bit, and let's turn our contours off. So now you can see it shows us, you know, the additional excavation we had to get down to our sub base as we build this. There's our paver area, there's our building pad, you see in the parking lot as well. Okay. So yeah, that's essentially that. One last little bit in our viewing is these reports. Let me see if we all right, so on our takeoff menu, I'm going to do a 3D drive simulation. And remember, we assigned some colors, and I'm going to say, I'm just going to start here. I'm going to start, let's change my, let's say I just used a pickup truck. Well, yeah, I'd say a Blazer. I'll be the supervisor. So it's going to give me a different, let's do bird's eye view, pedestrian view. And then, you know, you can set different lighting. And I'm looking at that surface. I can use different, I can turn on and off different aspects out of my model. And then when I could set my design speed. Let's go a little faster than that, say 10 or so. And not quite so high, let's up our, let's drop our distance a little bit. Okay, and then we're good to go there. We hit the run button, and okay, there we go. I hit it too many times. And so you can use the arrow keys on the keyboard and drive your way around it, and you can, you know, see it reacts to where those edges are as if you're actually out there driving it, so you can get a sense of. Now, this doesn't make much sense. It's more kind of like a toy, but you know, on a large site, this is sort of gives you a good overview. You can drive along it to make sure things are like you intended them to be. Okay, so again, just another means of visualizing your drawing. You've got, remember that quick profile. Let's just go across our site like this. And there you can see the various subgrades. You can see the original ground on that white line up there. If we turn off the original ground, turn off our design surface, that's the top of our design surface. This subgrade adjust and final target, that's because, you know, we didn't put any, they're exactly the same thing. We didn't have any of the additional topsoil replacement and that kind of stuff. But you can see as we come down here, as we start to track, you see out in here, I'm in the parking lot, you can see there's a subgrade, but I get into that island, and down here in our profile view, you see there's no subgrade there. We're back to the parking lot, no subgrade, back to the building. come out of the building. So that, again, just another way of helping you visualize what's going on. Here's another issue right there as we're coming on that curb line. We got a bit of a dip and a drop. All right. So that's the gist of that and some of the tools to help you elevate some things, how to take a look at some things. We had that problem with that little peak that it stuck over there, and there's some reason for that. That's something for tech support to try to take out, but we were able to verify it by building our surface independently and looking that it worked correctly. And this layers-based approach that Takeoff uses with these closed polylines caused a little glitch. But that is where we do with that. I'm going to hit save there. We'll come back after lunch and we'll put some borehole data in there and see how we can get the rock strata calculated from that. Okay. So if there's no questions, it's 1/4 We'll come back at 1:15 Eastern. Everybody good with that? Any questions on it so far, or think of anything else?
Yeah, just real quick, what button did you push to get the report of all the materials?
All right. I will stop the share. I will pause the recording. Resume the recording.
I'm here too.
All right, Josh is in.
I had a quick question on the last session. You, I know where to pull up like the volumes report, but where did you get the materials report?
From the Takeoff. Now I'm in I'm in R11 right now.
Yeah, that's fine.
So in this Takeoff, that'd be these material quantities. Standard or even custom if you wanted to set your own. So that standard report. And on this report tab, I checked the different things that I wanted to see reported. And then that brings up all of these subs and the cost. So my pads consist of concrete and stone. My parking lot has surface course, base course, and aggregate. My pavers have pavers and sand. And there's my total cost.
Got it. Thank you.
Now, another couple of other things that we can do is I'm going to go back to my defining layer surfaces. I'm going to put those text labels back into others. I don't need them anymore now. So I had, well, that's the building pad. We'll leave that one on there, but this elevation, I'm going to move that back to other. We'll save and exit. Now that sort of cleaned up our drawing a little bit. We're only looking at our design. And we can, you know, turn existing back on, that sort of thing. Now, some other things that we can do with our display tools, and that would be on our, you have a display menu or you've got the toolbar out. So we saw that we can display, you know, the elements that we used to create existing and design, but now you've also got under settings. We've built a design surface. We haven't contoured it yet, but we've got some setup here that we can define the different things we want to show. So under our existing ground, everything's turned off for there. Our design surface, we're showing the entities, but we can design, we can have it show contours, for instance. And if we go to the contours tab, choose our design labels, we'll just take the defaults here, 1 foot contour interval, draw contour index, change this to 5. It's the only one that doesn't automatically trigger. And we'll label the contours. We'll just put, yeah, just 2 per contour is fine. And we'll say okay, and we'll say okay. And now let me say update the model if we wanted. And there now are the design contours, and we can you know, we can set layers and text styles and heights and move those around on the contour line if we needed. But all right, so that would be our design contours. Now you can see from the shape of this one, that's where all those skinny triangles went across here, and you've got these big broad triangles out in here. So this would not really be something that I would build a surface from. You know, that contour really is should be going from, say, here just smoothly across over to here. You know, but this is following the shape of the triangles that we built in our surface. If we change that to, say, instead of drawing contours, we draw the surface itself, and we say okay, then it's going to draw the surface that we could look at in our 3D viewer. Oops, sorry. We'll get off of that. 3D views, these are just surfaces, 3D viewer window. So I'll select these entities, and they are now shown in here and colored based on those colors we use. Now you can also notice right in here, there's a couple of issues where there's a couple of, you know, there's some high points in this line around here, and it's dropping down to 0. So, you know, we would straighten those kind of issues out so that we didn't get those little blades up. Now, it's not affecting our quantities very much at all, but that is when we draw those resulting surface triangles. Now notice in this, come back here and turn that off. Now that actually drew those 3D faces right into my drawing, and I turn that off and re-display it, it erases them out. Now if we view the surface, remember that little high peak we had over here? We didn't do it in this one. It did it in the construction module under IntelliCAD. So again, I don't know what may have caused that. Also, IntelliCAD did not do this bit over here with the building pad either. So there's a couple of little glitchy things going on. And it looks like maybe one of these might not be closed, so it didn't separate that out. But in any case, those are some of the other options on this on display. And we also have cut and fill display. So you could draw cut and fill contours, labels, and a color map. Your cut and fill contours, of course, would be we'll label them again. We'll look at our cut and fills, just single, no indexes. We'll say okay. And so now when it displays the cut and fill, here's the amount of cut. You can see I've got, you know, a -1 foot there, -2 feet there, 2 feet of fill, 2 feet of fill. Now that's above the existing ground up to this top surface. So that's if you want those. And you notice the this green contour right here, that's the daylight line. That's the line of zero cut and fill. And if you do a color map, and let's look at our color fill map. We have, let's say 100 rows, and this is going to create a series of little rectangular grids and color them in. And we'll take this red, white, and blue coloring. We'll take 100 rows and see what it does with that. So that's going to put a display on here. And if we look at that, we zoom into it, there's 100 of these little rectangular shade, you know, that goes across and 100 that go up. That's what has set that. And when we zoom and look at it out here, this area in red is all in cut, and the deeper red is the deeper cut. Same thing in blue. The more blue you see, the deeper color blue is the higher level of cut. Again, back to my display settings. And if I put cut and fill labels on, let me see if I can label the cut. Put these elevations on there just to cut. Text style standard, text size. Let's make it a little smaller. Make it 2.5. We'll say okay. And so now it's gone through here and created, along with the color map, the amount of cut and fill all along that grid. You know, if that's helpful for you. And you can also be able to draw a legend. It's not prompting me for that. You can also, if we have strata data in our information, we can label the strata cut thickness as well. Yeah, I don't see the legend business on this, where it sets it up under that, unless it is do it from this command. Still doesn't prompt me. It normally would prompt me for a legend, and it would just draw over here what the various color shades mean. All right, so now what we want to take a look at, and Josh, under construction, yours is not available here. I'm going to open this back up as a read only, just to show you that differential. This is where you can put in drill hole data and define depths of rock or various strata, and it would separate those out in your reporting, and you can generate, you know, contours, generate surfaces from those, etc. And if we look at, you know, we don't have that drill hole menu on here. It used to be, they've since moved it to this other module called Geotech, and it has this defined over here, but you don't have that bit, but you can watch. I'll do this in Josh's. Now let me take a look at the color map here. It's still not prompting me for that legend. Oh, cut and fill map legend. You have to use that as a separate command, apparently. Yeah, so that shows you the relative amounts of the cuts and fills. So that's available.
So I can make a heat map on mine, right? Just not the drill hole stuff.
Yeah, same thing. Yeah, for the strata, and this will basically do the same thing with the cut and fill amounts. All right, so
Now, I'm just curious, you were pulling that from your toolbar. If I don't have that toolbar up, where is it hiding?
all right, and I'll take the legend off. Now I'm in. All right, so back in yours here, if you don't have that toolbar up, it's under takeoff and it's under surface tools. No, let me see, graphic reports. That's where it was under IntelliCAD. Under display is your cut and fill color map. That's everything on your display toolbar. It's under your display menu.
Got it. I'll be good with that. That's all I needed.
Okay, yeah. The actual legend came off of surface tools from IntelliCAD. Anyway, you could track down where that was if you wanted to draw your legend.
Right.
All right, so to illustrate this on the drill hole data, we'll take this and just extend through this example. We're going to have 3 drill holes located, one in this corner, one in that corner, and then one up here in the parking lot with some data in it. So we're just going to do some very simple stuff. Now you can import these from text files and from drill hole files. But we're going to define a dirt strata that's going to be 2 feet thick and a rock strata that's going to be 15 feet thick. And then we'll, and that's for our first one. That's our defaults. And then the 2 other drill holes. It'll be 1.5 for the dirt. We'll keep the rock at 15. And then for the third, we'll have 3 feet. So we're going to have 2, 1.5, and 3 in these 2 locations. So it's going to be here, here, and over here. So we'll go to our drill hole strata settings, and you can change your symbol, etc., all of that. We're going to add the strata we're interested in. And in this case, we're just going to put in dirt. And let me put these in all caps so you can read it a little easier. And we'll call that, say, 125 pounds per cubic foot, strength or swell factors if you need straddle model. You can either do it by depth, which would be the values you put in would be a read down from the top of the surface, or we're going to actually have the strata elevation. It's going to read that and build our model from that. What method that we're going to use, these are 3 different methods that it uses to compute the triangulation. Inverse distancing, either to the second power or third power, or least squares. And I don't know that they, in this old documentation, I don't think it ever even asked that. That's just some additional, this being our default, we'll take that, but there's some different algorithmic concerns here that if you're really into like geotechnical work, you would know which of these is going to produce the best results, depending on, you know, how far apart your drill holes may be. There's different strengths and different weaknesses of these different modeling methods. We'll just leave this at default. We'll say, okay, that's our dirt. We'll add a rock layer, and we'll call that one 150 pounds per cubic foot by elevation, same method. So now we've defined our strata model, and drill surface elevation for existing surface. Now that's sorry, a different one for the drill hole itself. All right, so now we'll say okay for that. And let's go in, and now we're going to see, here's where you can import through that text file. But we're going to place our first drill hole. And you can give it a station value or pick a location. We'll just pick right here. And here's where we need to put these in. Right now, it's reading the ground elevation at 81750 because it has a thickness of 0, but we're going to give that, and we could have an elevation here. You can put water table in, different things. Drill hole name, we'll just call that DH1. And if we edit that, we're going to give it a thickness of 2 feet, and that's going to come down here and change that elevation for the bottom. So it computes that as an elevation and stores that in the drill hole itself. We'll do the same thing for the rock, and we're going to make the rock, because we don't really know where the bottom of the rock is. We're just going to put it sufficiently below any of our excavation, because whenever we hit rock, we're not going to take the rock all the way out to the bottom. We don't know where that is. We just, you know, we drilled to refusal. So we just make it deep enough to where we know it's below it. So you can see a little sketch over here. You've got dirt sitting on top of rock, and that's for drill hole 1. We'll save that. And now let's put our second one up here in the parking lot. We'll give that a name down here, drill hole 2, and we'll leave the rock set to 15 feet. But our dirt thickness this time was, what do we say it was, number 2? Right, 1.5 and then 3. Okay, so this one will be 1.5. And we'll set the rock. Now notice it has a default thickness of 1, but we're going to put that back in as 15 feet. And then we'll save that. We'll put in our third one over in this corner. Call that one DH3. And this one was 3 feet thick. And this one was, again, 15 feet. Now I've kept having to now enter to end. I'm through. That's all the data I've got. If I go back to my strata settings, I had this check default last thickness of 1. You could have unchecked that and it would carry the last edits we made, or you could set that up to 15 feet. So that just filled out those defaults. All right, so now we've got our drill hole data in. And I don't think it puts these in at elevation. We'll see here real quickly. Yeah, it puts them on the surface, but it doesn't show them down here in the 3D view. The mining software actually draws those in with all the depth of the different strata. So now that you've defined the data, the next thing to do is to make the strata surfaces. Now you could have a strata polyline so that if you knew that, you know, the rock ran out over to within this area over here, or maybe it went around like this and there was no rock over here, you could draw those in so that limits the calculation. But we'll just go now and make the strata surfaces, and it said it created 2 surfaces. Now, what are those surfaces? So if I look at my views and I don't see a surface viewer here. Let's see what it into over here. That command is called cube score file name. Let me see if that also works for here. Cube underscore file name. No, it's not as a separate one, but to illustrate what those are going to look like, if I take a look at, I'm going to load up first my demo 1 OG. That's my original ground. Oops. So that will be like so. And I'm going to go to my model tab and add in those other surfaces. And they're called the same file name as the drawing with a -ch and then in sequence. So I've got 1. And I'll add also 2. Let's add. Oh, that's all we have. We have 3 drill holes, but we have 1 surface for the bottom of the dirt. And you can see it there underneath our existing. If we turn off, and then there's the bottom of the rock. So it models the bottom of the strata. So the dirt's pretty thin right in here. Over here, you can see it was it's the top of our ground. We were up in here. So it extrapolated that surface out. It actually peeks out through that a little bit because, you know, we didn't have, it's not following the top of the ground when it's building that surface. It's just going between those points. Okay, so if we turn off our original ground, then there you can see the bottom of the dirt and the bottom of the rock. They're not exactly parallel, and you can't really see that here unless we come back and put a little vertical exaggeration on it. Let's see if we can. Yeah, there you can see they're not They're not exactly parallel because they're different depths. Different relative depths between the two surfaces. Okay. All right, so we've got those two additional surfaces now. And what we can do with these strata layers, when we calculate our total volumes, we report strata, depth zones. Should be okay, I think. Yeah, so this summarizes the dirt and the rock and the totals and all there, different zones. And then if we do a materials quantity, we have strata. I think it's gonna. Give us that, and let's see some of the other. Calculator total volumes. Make the surfaces, calculate volumes inside a perimeter, cut and fill label, surface inspector, and trench quantities. Okay, so if we look at our surface menu and look at our surface inspector, oh, there's your cut and fill map legend. It's on the surface. Also the cut and fill color map is also here. It's odd that they put it like that. All right, so if we look at our surface inspector, I can find that it should have been there. Your surface tools. Let me put in view. Nope. Report. Volumes. We made them. We can draw the cut and fill, the color map, the surfaces themselves. We can do a drill hole report, which will just be basically showing us what's in the drill hole data. So drill hole 1, where it's located, the surface elevation, each strata, depth and elevation. That's basically just what we put in the drill hole data itself. I want to get to my surface. Inspector, maybe under inquiry. There it is, surface inspector under inquiry. So when we do this, it's going to pop up this little box, and we see we have the existing unadjusted design, targeted design, that includes the subgrades. And then we have dirt in the rock. So as I move around here, it's going to read you those elevations and then show you whether you're cut and fill and how much you are at any given point, just as you hover the mouse. So if I'm closer to this one, you see my dirt elevation is, 815.5, and my existing is 817.5. So there's my 2 feet. and look at it over near this one, that should be 3 feet. So 820.3 down to 819. Let's see, it went two, I'm sorry, 1.5, 2 to 1.5, and then the 3 is over here at this one. So 15.1 to 12.1. And then you can see all along the way how it's interpreting. It's interpolating all those values by reading the surface that it made when we made those strata. Okay, so we'll hit enter to finish that. Oh, you can also, by the way, when you run that command, if you click a spot, see, it'll label what that happens to be. What you're looking at here, it puts the label in there as well. And under O for options, you can set, you know, this symbol, what layer it goes on, how big to make the label. And it puts it in the current text style, which happens to be standard probably. So I'll just go through and take all these things off. And then finally, if we look at those strata maps under it's going to be under my cut and fill. There we go. It's under a drill hole menu. So you can draw the strata cut in cut depth contours or a color map. So if we draw that, and here's our 2 different surfaces. So if we draw the rock, we want to see where the rock, now that's going to be to the bottom of the rock. So if we go to the bottom of this dirt, that's the top of our rock. So we'll say, okay, and then there is where we are. So over here where we had fill, we had no, you know, we didn't encounter the rock at all. Everything above that was above that dirt. But when we're cutting over here, notice, you know, the cut is darker around these outside areas, and it's sort of lightish around that drill hole there. Now compare that one, if you can get a sense of what that looks like. And I'll take that back off and then show the standard cut and fill color map. See, there's a difference in how those work and what you're looking at, what you're displaying. So when you're doing that other one with the strata, it's going to show you that again, drill hole. So our strata cut. Now, obviously, it's not going to, we don't have choices to do strata fill because we're not trying to fill the top of the rock. We're just going to see, you know, how much cut are we into the rock at that particular point. And that's where we'll get those. Again, you get some, there's a drill hole, made the surfaces. And if you change or put more drill holes or change the data, you could clear the strata surfaces and then remake the strata surfaces. So it rereads the data and makes a different strata surface for us. Okay. So that's pretty well the thumbnail sketch of that. Now, the other part that you have, and again, Josh, you don't have this in yours, you would have to get the trenching module. We won't go through this, but I want to point to you in this, in the tutorial manual, the one that has, you know, like 800 or 1,000 pages. There's a part here with this trenching example, and it shows you, you know, how you come up with picking these lines, putting in depths, and you define the trenching, color zones. So, you know, see up here means if it's red, you're between 0 and 15 feet. If it's yellow, it's 15 to 20 feet, green, 20 to 25. And if it's cyan, it'd be over 25. And you can set all those different ranges and such. And when you draw that, it will draw it. You can even generate profile views of those trenches. So I'm going to leave that to your investigation. When you go through this book, now it's going to tell you to open this file called Takeoff Demo 2. And I don't know if that's got the same name. I think it's just called Demo. No, it's called Demo 3. So Demo 3 would be the file. Well, go back to the original. Remember what we did is we erased those pipe center lines that we had in there for the first time. So go back to that original if you have to re-download it. But you can grab that from there, or I think it may have placed it all the way up here in Carlson projects. Yeah, there's a Demo 3. So it would be there, and there's your and that's just part of your standard installation. It's right up in Carlson projects as one of the sample files. So that gives you that information. You've got, you know, the inverts in and out and such. So it helps you build that based on this set of steps. Okay, so I'm going to leave that to your own study, since Josh would just sit there and twiddle his thumb. He doesn't have the trenching module. But when we over on the CAD based one, not the standalone based one, if you had the trenching module, it basically just puts in the same commands that you've got under your trench menu, and you can build a utility network. So you put the network of those pipes together as a utility. Okay, so
For the purposes of kind of what we do here, we don't do a lot of pipe work, but sometimes I can see how it'd be useful if we have like a big culvert or something. Is it possible to, I guess, treat it as a road or something and do a road center line and make a model that way with the different layers?
Absolutely. Yeah, you would just put the center line down the pipe or the culvert or whatever, even if it's you could even do it with a whole network of sewers. And then you make those center lines and you define your template to be the width of the trench, and, you know, it goes up at a certain slope to hit the existing ground, that sort of stuff. In fact, that's one way that I used to do trenching design with this, you know, without the trenching module. The trenching module, you know, generates reports based on just the trenching work, and, you know, and it color codes those pipe runs as to where your depths are. So you know where to put in your shoring and that kind of stuff. Although I think, at least in Pennsylvania, I think you have to have mechanical shoring in if it's over 5 feet deep. I don't know what it is where you guys are. And that might be federal. I don't have any idea. But here in Pennsylvania, if we're over a 5 foot depth on there, we have to have mechanical shoring when we're working in those trenches. So that's you know, a couple of tools for that. And it also will do, if you have GPS driven backhoe, you know, excavators, not just bulldozers, it can actually use that surface that you generate to drive the excavator. So, but again, you can do that just by treating it like a roadway. You just define your template to be the shape of the trench.
Got it.
Okay.
Yep.
Now, let's take a look at, since you both have some of these road tools, and the one thing I want to focus on that will, all of these are individual things to do with center lines, and you got some profiles where you do create profile, do all these different things, but it all comes together in these two things down at the bottom. If we process our road design, over here's where we pick the file that we're going to use, and then over here are the edit buttons. So that basically goes and finds that command out of that menu and lets you edit it. So this is where you would do it. And this road design, the one I chose, that one option is just for like a single roadway. And, you would do that one particular road. However, if you have intersecting roads, the other option is this road network, in which case you would, give it a file. We're just going to call this one test at the moment. And this is where when you add a road and then you add another road, if they cross or meet at a T or whatever, it automatically determines where the intersections are, and it will process based on the different templates, potentially different templates of each of the different alignments, and it will match in the the edges of the asphalt. It'll go around those intersection radii and put those in for you and process all the cut and fill down to the existing ground. So we'll take a look at that through this process, and just knowing that when we pull it from those particular tools, either road network, which I haven't started one yet, but either one of these, doing it from this little central command center is the same as if we went and chose these various inputs and edit types of commands. So we won't have time to get into all that. It's more of a civil design class element, but since you guys do a lot of road work, I want to show you how that part works. So we're going to close these files. Go back over here and save this one with the drill hole data, which won't have any effect over in the other module. And I'll just close these off. All right. So now back into this one, we're going to open a file for our road design. Let's see which one we're going to use. Let's see, there's our grading. Yeah, we'll take that road design. All right, so we'll take road design base and we'll open that up. And this would be a file that we get in, we would use this to generate our existing ground, that sort of stuff. Now, let me show you a little something about this file. And over here, Drew, let me see if this is in. If you have these same tools, I'm going to come down here and find this road design base as well. Say read only, yep. Okay, save a new update any, okay, understood. So now what's happened when all this stuff came up, if you click on that, any one of those contours, you're going to see that it is a one single object. I look over here in my properties and I see it's an AutoCAD proxy entity. And under full AutoCAD, you would see all kinds of things about that. That's actually a surface object that came out of Civil 3D. Right, so what I was checking at in your version is if you have, yep, you could do the same thing. So we're going to do it from Civil 3D, and we'll get that taken care of in this fashion. So I'll switch back here so Josh can, so Josh can follow along with this one as well. All right, so we've got a contour map. Again, it is a single entity. It's a AECC DB surface triangulation file. See, it recognizes it here in this full thing. And it's got, look at all these different properties it's got. Layer it's on, line weights, etc., typical CAD stuff. But then it's got all of these things that go along with it being a surface, whether it casts and receives shadows. Let's see, anything else that can help us? Not really. You could specify a material for it if you wanted. There's no real, you could turn it on and off, but it doesn't do much for us. So what we want to do though is to use that to build our surface. Now we could explode it and then explode it again. It explodes it down to a block. We could explode it again and we get these individual lines and build a surface from the contours. But because this surface has already been built as part of this Civil 3D file, we're going to be able to import that directly and save it directly as a TIN file that we can use as our existing ground. Now, one thing too, you see those skirts that it drew, those are all a bunch of 3D faces. And so we're going to while I've rotated it here a little bit too, and in the IntelliCAD version, if you set your view style, which sure. Yeah, so under current visual style, if I just say realistic, it's going to shade in. Now these, when I viewed it around in a non-planned view, because it's a surface object, it calculated all those as triangles. If I go back to my plan view, see it's like this, but as soon as I shade that, you're going to see those show up as shaded triangles. All right, so that's sort of, some of that behavior of this as an embedded terrain object. All right, so what we'll do, let me go back now and set that current view back to just 2D wireframes, fine. And so what we're going to do is once we get this done, we're going to erase all of those 3D skirts down there that are drawn in here. We don't really need them. If I try to do it now, it's all part of this single object. So we're going to break this apart as part of this next step. So we're going to go to the file menu, and because we know it comes from Civil 3D, we're going to go to import Civil 3D. And now we could say all objects, but I can tell you that there's nothing else in here, just a surface. This is what we're going to use to make an alignment, but we'll make our own alignment from that with our road tools. So we're going to choose surface, and it's going to read the data, and it said, hey, I found a surface called phase 6 original ground. Do you want to create a Carlson 10 surface? And you can say, yep. And it's a triangulation file to write. I'll just keep that same name, the same location. I'll say save. And it will say there's one in there already, but and just, as part of your sample data. So now I've located that. And if I select these now individually, they're all individual polylines at elevation. You see, so it's at the elevation. There's 90, there's 125, 120. So you see that it's all there. And now we have this, which is on a layer called C-topo BNDY. I've also got across that. I want to keep that outside polyline. So so I'm not going to erase by layer because I want to keep that and use that as my surface boundary. But I see that's on a layer called C-topo boundary, so I can't do an erase by layer, but I can, I can. So in fact, I can use a filter on there. So let's go to edit, erase by layer. And we'll select the layer from the screen. We'll pick one of those little yellow skirts, but down here where it says all, we're going to uncheck that and just say, it should be there's a 3D face. We say okay, and now it's cleaned those out, and we're left now with this 3D polyline that we can use as a boundary. It doesn't have to be 3D, it can be 2D. Okay, now we'll go back to plan view. I'll just type plan, hit enter. And now we could create our surface, our existing ground, by modeling the contours and all that, which we would get, further and further away from the truth. Although I think when they built this in Civil 3D, they did that very same thing. That's why you have all these flat areas out here, and it's really kind of not a superbly well modeled surface. If I look at it in my viewer, you can see a lot of these flat areas here, where those contours ran out. So I think that's exactly what they did. If I turn on my contours, set that back to, I'll say, a 5-foot interval, and then turn on my triangle edges, you can see that, everything went, actually, it even, it's like it's skipped, unless that's just a smaller triangle across it. So, they modeled their surface from those drawn contours to begin with, but we'll live with what they gave us. All right. Now, if I were doing takeoff work like I did on that other site where I'm going to put in subgrades for buildings and things like that, what I would do is in my define layers for existing, I wouldn't go and just pick these layers. I would switch my source from layers to file. I would select the file and choose that right there. Save and exit. I would set my boundary. Now I've defined my boundary, and if I make existing, I've now have that file, and if I view, and this is called, that was the original separate file, but I've got this file called roadway design base, and I should see that up in here with that OG. That's my original ground, and that's exactly the very same file. We took that in here. As you can see, it's probably a little data point error, but that was because we told it our source was a file. So all it does is go out and reads that file and gives it that label as being my existing surface. All right, so that's where you would take that and assign that instead of having it compute by layer membership. We set it to a file because we already had the file. Okay, so on with our road stuff. Now this is going to be done sort of separately outside of that existing surface and design surface concept, that two surface concept like we saw with all those other earthwork things. We're going to actually use named surfaces. And we're going to design this roadway. And in your case, when you get a road design in from another design company, all of these things are defined. You're not going to have to define the road. You just type it in from the data that you see in the plans. Okay. So we're going to do that and just sort of make us a dummy looking road, and instead of road network here to illustrate the concepts. So let's go straight into roads network. And we're going to select the new tab at the top. I'll give this a name and we'll call it, let's call it road. Let's just call it road network. Okay. And now we have this docked control panel over here that has a bunch of things that we're going to use to help us build this network of roads. And the first thing I want to look at are my settings under this gear over here. So I click that. I got a bunch of different options up here. And if I look at my process options, I can tell it my existing surface. Right now it says none, but I would choose that phase 6 original. In this case, you could also choose that. It's identical. And you can see even down to the byte count, it's identical. So now I'll choose that phase 6 original. I'll open that. Now this rock surface, remember the drill holes that we did in the other job? If you had drill hole data here and you did that make strata, that would be a rock surface, which would be the bottom of the dirt strata, which is the top of the rock. You could set that to that as well, and that would take that into account when it goes to compute your cut and fill volumes. All right, so we don't have it for this one. We're going to go along now. The station interval, when we drop our templates along our alignment, you can set it to be anything you want, 25 feet. And as we go through an intersection, 5 might be a little tight. Now we'll leave it at 5. You could make that maybe 10, but that's when you get to the intersection, it's trying to blend two different corridors together. And that's, so you're going to want those template drops to be a little closer together in there. Now my existing section maximum offset, when it goes to cut and it figures out how much cut or fill is going to be involved in this road, it needs to go out sufficient distant to where it's going to intercept the original ground with the side slopes. So if you have this too low, let's say it's only 50 feet, and you've got, in this case, you're going to see some really massive cuts in coming through this mountaintop here. What happens? It doesn't keep it from processing. It still processes, but when it accumulates the volumes, it stops at that 50-foot limit and doesn't count the additional cut or fill that you'd have outside of that 50-foot width or 100-foot total width. And what happens though is it will tell you when it's running the reports, it will tell you, hey, you exceeded the width. And so you would just come back here to your settings and you would give that a sufficient width to check it. Now, if everything is real flat and everything's, just a foot or two away from existing ground, you don't want to have it spend the time to go look 250 feet, 125 feet each direction. You might tone that down to maybe 50 feet or whatever offset distance you might need to catch the outermost daylight line. So this may or may not be sufficient. We'll see. Now this process on updated design files, you have two different things here. You can off or you can have it prompt you if something's changed, or it will automatically update. Now what that means is if you've processed it after you've got everything set and you go, oh wait, I need to change the profile over here, I'm going to raise this up, or I'm going to move the alignment slightly and some different, you've got some change to accommodate. If you have it on automatic, as soon as you make that change while you're in this system, it's going to automatically recalculate everything and redisplay everything for you. So sometimes that can, get in the way if you're making several different changes at one time. You might want to just have it prompt you and you can say, no, I don't want to calculate yet. I know I got to go back and reprocess. So that's my choice. And our slope perpendicular to slope direction or center line. And these have to do with side slopes on our, not so much the pavement cross slope. That's always going to be held based on our template, but it's the slope of the cut and fill banks on the outside edges. As to how it, when we tell it we want to go to a 3-to-1 slope, that's going to be either perpendicular to the slope direction of the edge that it's starting from, or it's going to be perpendicular to the center line. And so those things, wouldn't, if you say it perpendicular to the center line, that's the horizontal center line. So it's going to always be perpendicular from the road alignment as it computes those. If you say it from the slope direction, it's going to, if that edge of that road comes up here and it's climbing up a hill, then the slope is always going to be perpendicular to that inclined line. And that's our more conservative approach, because what happens is, let's say you have a limitation on your job that you may have to say you can have no slopes greater than, say, 2-to-1. Then if you go perpendicular to the center line, but you've got an inclined slope direction, the contour spacing, the contours that it would draw for that finished slope would actually be closer together because it's drawing them perpendicular to that flat alignment instead of perpendicular to the inclined alignment. And so, and it makes for smaller cut and fill extents, but it makes the contours tighter. And so somebody, some junior inspector in the approving agency office gets out his scale and he measures the distance between the contours and goes, hey, your slopes are too steep. So this is our more conservative approach on that choice. So we'll just leave it at that. Now, this down here is whether or not we want to tie it to existing. If we don't check that, this is where I was telling you earlier this morning, you can do road designs and it will build the whole structure out to the last edge before it does the cut and fill bank. But you still have to have this surface or it won't run. So like I said, it can be a dummy surface. It doesn't have to be in this area. It could be from that last job we just did if we uncheck this tie to existing. But we have it here, so we're going to tie there and we'll see the side slopes. Now, some of these other things, I'm going to skip over output options just for a second, and we'll look at the report options. And this is the precision. I'll go to the nearest hundredth for distances and such. You can use the report formatter where you can build your own. With the formatter, we'll leave that off and just take the standard. We want to report cut and fill end areas and differences, yes or no, shrink and swell factors, subgrades, topsoils, if we had those defined as well, and then accumulate the amount of cut and fill as you go down the alignment, right? That's what all those mean. Our display options have to do with when we select a road over here, it's going to indicate in our plan view which road we've selected, and we can either have it dash it or we can thicken it. So I'm going to thicken it and you'll see what happens. It's just a display thing, it's temporary. And to highlight the current intersection, now intersections and cul-de-sacs, you tell it where the cul-de-sac is going to go, the end of one of these alignments. Intersections are found by the fact that two alignments cross or meet in a T. And when it displays, once you choose a particular intersection, it will draw an indicator. In this case, it's going to put a circular looking target around it, or you can have it use an arrow pointer. So that's just your choice there. Under my defaults, and again, I'm just setting up defaults and I can override these at any time. This is going to be the, up here in this upper block, this is what happens in transitions. And the transitions mean if I'm coming down here and I've got a road that crosses, well, my edge of pavement is going to come down like this, and it's going to come down this one like this, but where they meet, I need to put a return radius in there so that it blends smoothly as a nice circular radius across there. And that is the default distance of that radius. So if you're not intersecting exactly perpendicular, let's say you're at a real skew angle, you might have this one to be a smaller radius than this one over here. Is going to be a much greater radius to make that smooth. And so you can override those individually as you need to. This is just setting up a default. Centerline intersections. When this center line crosses another center line in the profile, it's going to put little vertical curves around that crossing so that we can take, let's say this is our main road and we're going to hold that crown and we cross it with this road. When this profile comes up, it has to get across this road. So it comes up here and it sees the side slopes down from that pavement, and it puts a little vertical curve to match that little climb up to the crown, puts another vertical curve right at the crown, usually of a 0 length. And then it goes down the other side and then puts a vertical curve to transition back down to the tangent of that road profile. And that all gets built automatically when it finds the intersection. You don't have to do anything with it. Okay, so it will make those transitions for you. And these are, again, default lengths that we're going to just hold. And this PVI distance is the distance from the center line where it crosses out to where that other curve starts against that roadway to get you up to that pavement. So in our case, if we're going to have a 12-foot wide lane, we're going to go 15 feet. So it'll be 3 feet outside the edge of pavement where it puts that other little transition vertical curve to come up and cross the crown. For side intersections, a vertical curve length. Now this has to do with those transitions as we come around there. As it builds that pavement edge radius, we could have no vertical curves, or we're going to put a default 25 footer in there so we can individually edit those to, like, maybe put a low spot in it, to put an inlet in, all kinds of things we can do with it. But again, we're not going to focus real deeply today on the nuances of designing a road. Somebody's already designed it for you. And different methods of how we model the surface through the intersection. We can hold the main crown, or we can go radial from the curb, so it will blend smoothly from either the edge of pavement or the face of curb if we're using curbs on our template. And but if we hold the main crown, then as you go through that intersection coming across the side street, it doesn't flatten out the shape of the pavement of the main road. It holds that crown, but it blends the other across it. So you might set the hold main crown. Profile method is you can allow a single PVI if it can do it with only one. Let's say if your tangent is coming up, your vertical tangent, and it meets that pavement at the same slope, it doesn't need to put a PVI in there. So it would only put one maybe on this side. So that's allow single, or otherwise you could say always create for grades in and out, or don't have it automatically do it and you have to tell it where it goes. So allowing single will give you a little bit of flexibility there. And then finally, the transition method has the pavements go across. It will actually draw the edge of that crossing pavement and stop it at the midpoint of the intersection, or go all the way through the intersection. So I'm going to go all the way across it. Now, cul-de-sacs, this is again default value. The center line design, left to right or right to left, and that is talking about the edge, the pavement edge as it goes along. So if our road is increasing in station this way, when we get to that, and well, let's say we have a cul-de-sac out here, and then we say right to left or left to right if we want it to station our cul-de-sac in that particular fashion. We have standard teardrop or straight edge cul-de-sacs. Standards puts those little curves in as it draws the circle. It'll, blends the little curve to come back to the straight part of the pavement. Default radius values. The fillet radius, that's that little transition curve between the circle of the cul-de-sac and the edge of the straight part of the road. And if you have an offset cul-de-sac, like you come up here and you want it to be all, say 25 feet up here as it creates the cul-de-sac around, it's not just centered, but maybe all on one side, then this one will actually extend the center line. Let's say if I'm going this direction, I hit a cul-de-sac, and instead of just ending my alignment at that station, it will actually draw an additional piece of that alignment until it hits the center of that offset cul-de-sac and stop the alignment there. So whichever way you want that to work is fine. Again, just defaults. Vertical curve lengths around the cul-de-sac, you can again put one in automatically, and that you can adjust individually if you need to make changes to those edges. Road design parameters, again, you're not going to need them, but that is, you would go out and find a file, and it checks things like all kinds of things, speed tables, sight distances, all those things that you're not going to need to worry about. All right, so now back to the output options. Here's where the magic happens. If we say we want to triangulate and contour, that means we're going to design a road, we're going to have it process, and it's going to generate a surface. And if we check this on and we hit the setup button, we'll do it in a minute, and I'll show you what we'll define all of that about that roadway surface. You can also have it automatically merge in with the existing ground as a single composite surface, and you give it a name by choosing set. You can also do that with those surface utilities, with triangulation file utilities. You can merge into the other if you need to make it a single contiguous surface. We'll leave that off for now. Now, here's where you can output, say, just the top grade. That would be like you were doing those cross sections, Josh, on that example we looked at this morning. Or you could have it actually kick out a subgrade as a surface automatically. Now you can also, even if you do this, you can still come back later and pull out those subgrades as individual surfaces. Writing a serve CE stakeout, that's so that you can create the data and put it on a data collector, give it to the surveyors. They can go out there and stake the road. Again, it won't matter for us. We could draw the template polylines. Now those are things like the edge of pavement, or the center line, the edge of pavement, the face of curb, top of curb, back of curb, sidewalks, any of that kind of stuff that's defined in the template. We could have it draw those as 2Ds, yes or no. also have it draw the subgrades as polylines. And if you choose that, then you could choose which of these subgrades to draw. Now, we don't have any to pick from yet when we choose select because we haven't built a template yet. But anyway, let's take a look at this, and we're going to generate the top of the surface, and that's going to be the 3D line work that we generate in the drawing that we can look at, but we're still going to get the subgrades in our reporting. Let's see, anything else? You can cross sections and all that kind of stuff can all be done out of this as well. You can label profile information. You can output coordinates. Now, I had this checked on from the last time I ran it because what I typically do is in my setup, I'm going to, and I would choose the template ID. Again, I don't have a template yet, but I had an EP for edge of pavement. And if I have a template already defined, I hit select and choose it. And I wanted to draw points. I had to give it a file name for the coordinate file. So it's going to draw a Carlson point on both sides of the edge of pavement where the description will have the station value and the offset in it, but it's going to be the profile low station. Now, why might you want that? In a case like this is all along this network of roadways, wherever that profile goes through a sag vertical curve, the pavement on either side of it, that's going to be the low part of that roadway corridor in that local area. If I drop a point in those locations, I then know where to put an inlet automatically. It's already showing me where the lowest spot is, and that's where my inlet needs to go to catch the water. So that's why I had that checked when I know, yeah, I'm missing coordinate file. No, that's when I normally do those coordinates. We're going to uncheck that. We don't need to do that part. You can generate the edge of pavement profiles and do all that kind of stuff as separate profile lines. It generates those automatically anyway and holds them in memory, so we don't need to worry about doing that unless we have to draw them. Elevate pads and lots. If I were building a subdivision and I have a network of roads going through there, and I've got building footprints and lot edges, and I haven't done my grading design yet, I can let my road take care of doing all that design for it. Again, that's more design. We're not doing that. We're going to just put in what somebody else has given us. You can set layers for the different elements that it's going to kick out. Their disturbed area is going to have a perimeter around it on a layer called perimeter. And let's see, output file settings. These are some files that we wanted to automatically generate, and we're going to get these little extensions on the file name. So our existing sections will say EX, our final sections will say FN, any rock sections, intersections, profiles. That's the profiles around those little pavement curb returns as a profile file, but it's put an INT in it. Same thing with the it's a default intersections. All right, yeah, that's it. That's the profiles that it generates, and this is the centerline files that it generates. So it's going to put a -int.cl and a -int.pro. And again, cul-de-sac, -cds, and then an existing profile that's going to read the ground wherever my alignment goes, create an existing ground profile, all automatically as part of this process. And I'll go ahead and have it generate that, and it'll be -ex.pro. I can do also existing grounds at particular offsets left and right. I stipulate the distances if I need those, but I'll take those as my defaults. Okay, so back up here, the last thing we haven't looked at is under triangulate and contour, we need to do setup. And if you've ever done your manually where you manually create your surfaces with the triangulate and contour tool. This is what you see here, with the exception there's no selection tab over here. So we've got different things. So let's look first at the contour lines. We'll have it draw the contours, and we'll put this one on. This is going to be CTOPO-MINR for minor -RD for road. And it's going to be a 5-foot contour interval because, again, this is pretty steep terrain. And I'm going to draw separately my index contours on CTOPO major -RD with a contour interval of 25 on those. No smoothing, none of this reduction. I don't need to worry about that. My computer can handle all that. Now, finally, back to triangulate tab. I'm not going to draw any of these objects in my drawing file. Again, it's all part of the surface. I can always get them later. But this set color and layers button, if I choose it now, I don't have a template. So, but it's reading what I had shown last time. In the template I used last time, I had this grade ID that would be, you know, EOP or EP for edge of pavement. This is the top of curb. This is right of way. And so these are colors that you're going to assign when it builds the surface so that you can actually see them colored as these specific colors. We'll come back to that after we build our template and show you how that works. And then finally, I want to write this triangulation file that I'm going to output. This is going to be my roadway surface. So I'm going to hit select, and I'm going to just type roadway surface. That's going to be the name of the TIN file that it's going to generate. Again, don't forget, on most of these dialog boxes, you can load and save the dialogues. I'll say okay. Now everything is good to go on my setup. I'll say okay and be done with that. Now, at this point, like once you go through those settings and you get that stuff set up correctly, the next time you do another road network somewhere else in another site, whatever, you can open a road network file that you've already done, and it inherits all those settings. And then you would do a save as, which is this little button, and give it a new name up here to match your project. Okay, so that's going to help you carry a lot of that stuff forward. Or you can just create a new one. You reset some things back. Now these buttons here is to add a road. We haven't got any roads defined yet. This is to edit those given roads, but you can just select the name and double click it. That does the same thing. Remove will take a particular center line out of our network. And down here we have the process button. So once we got things, changes made, and we hit the go button, that's going to calculate everything. These are our reports. The draw command will take, if we select a road and choose draw, it will draw that center line in for us in case we've lost it out of our drawing. Now that's the same thing as if you go up to the road menu and choose draw center line file right here. All right, so again, everything is sort of contained in this big system. Now, let's go ahead and start. And we look over here and we see this is going to be our start of our alignment. This is going to be the end of our alignment. And you'll see how this automatic processing works. If I add, I need to tell it I'm going to add a road. How do I want to select it? I either have a centerline file already made, or I'm just going to screen pick a polyline. In your case, because you are reading you're going to probably build your center lines numerically from the plan set. So you would go ahead and have a centerline file and you would use that, and you could use the draw button to draw it into the file here. Or you could have it drawn like you did in the that geometry base file that we looked at this morning, Josh, on yours, where you had those center lines drawn. You could pick it there if you haven't made the file yet. Again, same thing as if I went to my roads menu and said polyline to centerline file. So I'm going to say screen pick a polyline. It asks me to select it, and there it is. I'll check it, and it says there is no centerline file associated with it yet, so I'm going to assign it. So I'll choose this, and I'll give it a name. I'm going to call this one, let's see, I've already used Main Street down here for some of this other stuff in your sample data. Let's call this one MLK Boulevard. Every city has a Martin Luther King Boulevard. We'll call it that. Okay, so now that's our main road, and we have it. You see how it shows up here. And now it's going to ask us immediately for a design profile. Again, we haven't done it yet, so we're just giving it a name. So we'll say save. And it brings us to Command Central here. So here's the road that we're working on. Station gap settings. Let's say if I've got a bridge somewhere in between here, I can interrupt the processing so it doesn't process within those ranges. I can limit the station values. Now it's a 1,360 foot long alignment so far, and there's no curves in it yet. So if you just want to look at certain parts of it and you don't want to take the whole alignment, you can limit it there. All right, so the first two things that it did is it went ahead and identified these associated file names. And their center line is just, the tangents. So I'm going to choose edit, and it's the same thing as if I had chosen that menu or double clicked it out in the drawing once it's a center line. And now it wants to know a coordinate file to process. I'll just hit the new tab and do this. That's because of some of those settings. It was trying to output a coordinate. It's not going to have any effect on us. So I just gave it hit the new tab and took the default. So now you see the alignment here, and I'm going to fit some curves in there. So if I'm sitting on that first incoming tangent, I'm going to fit a curve. And again, you would have all of this stuff defined for you in your plan set. Let's see what a 75-foot curve would look like. And you've got, horizontal speed tables based on design speed and all of that. That's, again, more for when you're designing. So I'm going to come back here and make that a 75 foot. And I'll say, okay. And that's just really tiny because it's a large site. I'm going to maybe double click that curve and change. I'm going to hold the PI points. And I'm going to now make sure it stays tangential to the previous element. I'm going to double click 75, and I'm going to make it 250. Let's see what that does for us. All right, that's a little better as a curve. I'll go down to my next one, and I'll fit a curve. And let's give that one a radius of 200 feet. See if that'll work. Yeah, it comes right close to the end. It's a little bigger because it's a tighter change. Maybe let's come back to this one and up it to 300. Tangent, hold the PIs. A little broader curve here. I'll take this one, hold the PIs, tangent. Let's make that one 150. All right, so, and again, that's given to you. I'm just getting something that's sort of smooth and even looking. And I'm going to say save and exit. And see what it did, because that linking is on in my settings. It went ahead and redrew it and put the curves in for me. Now I've got that done. Now, my design profile if I edit that, it's going to put me in this profile editor. And I've got a fit vertical exaggeration. That's what it looks like in real life. But fit will let me really see where I'm working. And so what it does is it starts at the beginning, goes to the end, and it puts it basically a zero depth. It puts it on the ground. It's a little bit less than zero there, but so that starts me out here, but I need some vertical curves in between here. Now notice this red line, that's my existing ground. And if I look at my setup button at the bottom, that's where I can say down here that I want to output that reference surface, that's the existing grade. It's going to have a suffix of -ex, and then it would have a file extension of .pro. I'll show crest points, show vertical lines for intersections, which you won't see yet, but if I had a road that crossed this, you would see a vertical line here indicating that. Showing the reference surface, if you didn't want to see it, you could uncheck it and that goes away. Let's just leave these as they are. And these are options that control your editing up here. Again, you're not going to do a lot of visual editing with that because you're going to have this stuff already defined. So let's put some things in here visually as if that was what were given to us in our profile definition. So I'm going to come down here and look at these buttons, and I've got this one that is a plus mark that's going to add a PVI. And this button is where we, if I can get that to go away, is where we edit a PVI. So if I add a PVI, I'm going to put one, say, right in here. I'll leave these snap values. I'll snap to the nearest 5-foot station, nearest 0.5% slope. So it reads it at station 350. And it read the elevation right where I clicked, gave me my slopes in and out. And I could put a sight distance in of a certain requirement if I had that, and I would say, okay. And so now that's got a slope. That's a PVI right here, but it has a 0 curve length. So let me come back here for a minute. Yeah, that's all right. So when I click down here, you see it goes to those individual PVIs. And if I come over here, and I'm going to make that say a 400-foot vertical curve, or let's maybe make that 200 feet. There we go. All right, so I've got that there. I'm sort of on my existing ground down in here. I've got a huge mountain to get through to get down to here. So I'm going to go back and add another PVI. And I'm going to say, go from that point, I need to climb up here to the top. Let's say I'm going to go here. And that reads my station. Here's my vertical curve distance now. I'm going to make that one, say, 350. And so now it's put that up there. So it kept me down here, kept that slope the same, but to get up to this one, it had to come up this slope. Now look, as I'm tracking on that tangent, you read up the top, that's a 16% slope. That's pretty much a no-no for good highway design. But in any case, for the purposes of illustration, we'll live with that. Now this incoming slope here is 5%. That's not too bad. If I'm going to come down here and try to match something that's going on, looks like my original ground is trending in that similar type direction. I could just leave that slope as it is, or I could add another. Let's add a little transition slope down here. Oops. Tells me it's too long. Yeah, I know that. So I'm going to change the slope of the curve length. I'm going to just make that a 50-foot. Let's see what that does. Maybe not quite too small here. Let's make that 100 feet. All right, so that gives me something so that my closing profile grade, if I'm on that portion of it, I look at the top, it's a -7%. I may grab this little edit button and just sort of pull that down to where it looks a little flatter. Get this edit button. See, I can match the original ground in here as I come up. Maybe I needed to pull this one down so it's not so steep, or, you're trying to sort of match to sort of balance the cut and fill. And again, you're going to get that a little better control here. You're going to be given those values. I've got this thing, it's a little too sensitive. All right, so we'll take it like that. So our road's going to be some fill in here, cut and cut, a little fill in the middle. All right. So notwithstanding our crazy slopes, it's 14%. There's almost a 15%. So I'm going to say save and exit. So now I've defined my profile. And again, I could go to my, after I'm off this, I could go to my roads menu and choose edit profile file, and it would load that up for me. Now my design template, I'm going to choose that button. Right now I don't have one, so I'm going to say new, and I'm going to call this 12 foot, that'll be 12-foot lanes with curbs. Okay, so that will be what I'm going to use on MLK Boulevard. All right, so it's there, it's named, it hasn't been designed yet. I'm going to hit the edit button. And again, here is where we're going to start to build that typical section from your plans. And we do that with a series of grades for the tops. We put curbs in when we have curb structures, medians if we have a median, and we have subgrades that help us define the thickness of the materials under it. And you've got super elevations, cut and fill banks, right-of-way design widths and all of that. We're not going to get into full road design. Again, we're just going to take a bunch of the defaults. The left side display, I'm going to show in fill. The right side, I'm going to show in cut. Now that means it's going to show only the fill slope over here and only the cut slope over here. A lot of places you'll see where they draw them both in, but this is just for display purposes. It determines whether it's in cut or fill based on the surfaces, and it reacts accordingly. Right side, same as left. Again, the simple case, it doesn't have to be. So when I do that, my right side stays grayed out, and you'll see. So I'm starting here in the center. I'm going to put a grade in. This is going to be from the center line out to my edge of pavement. So I'm going to click that grade button, and I'm going to add a grade. And how do I want to go from the center to the edge of pavement? A percent slope, I'm going to say I'm going to go down at -2%. Some people use 2.08 because that's a 1/4 inch per foot. Horizontal distance, remember I said 12-foot lane, so I'm going to be 12 feet. And I'm going to give that a ID of EP for edge of pavement. And I'm say, okay. All right, so now you see right side same as left. It's got them both shown. Now at this point, I'm going to put a curb in. And you see different kinds that you have. Here's a drop curb. We've got, the 1, 2, 3, or 4 different types. We just stay with a standard curb here that has a curb and gutter. We will make the curb separate from the pavement itself and the subgrade. Otherwise, like concrete road slabs that are built integral with the curbs, you could make them that way if you wanted. Dimension units, I'll set to inches. How do I want the bottom of that curb to be? Either flat, or I can match the crown slope or give it a special one. I'll just keep it flat. Now my dimensions, I'm going to go my top, which is from the back of curb to the top of curb. That's that distance. So I would make that, typically it's a half a foot. I'm going to make it just a little bit short at 0.45. And then
Are these in inches or feet now?
they're in inches because right here where I said dimension units, I chose inches.
So that's 0.45 inches is what that's saying.
Oh, thank you. Thank you. I knew I should have slept more last night. Yeah. So, yeah, I was just cooking right along. All right. So in terms of inches, that's going to be, instead of 6 inches, I'm going to call it 5.5 inches. So I'm going to say 5. So I'll use a 1/2 inch taper then. So that will give me an automatic, you know, from the back down here to my face will be a total of 6 inches. And then my width, that's my gutter width, and to be 12 inches there. My height, 6 inches thick. My height too is 12. So that gives me a 6-inch high from the face of curb to the back. Or actually from out here at this point. Now my base dimension then will add this width, taper, and top, and comes up with a full 18 inches as a curb. All right. And again, I can go here and I'm going to give it a material assignment of concrete. And then I'm going to give it an ID of just CRB to let me know what it is when it calculates my volumes. All right. So that's the curb I'm going to define. And again, you can save and load different curb types, give them names, and just come back later and load it up. You don't have to fill this out each time. And I'll say, okay. So there it's drawn the curbs. Now you can do some interesting things with this. If you change that to a right facing, and then you moved it up, well, except it screws up the draw. But you see, if I'd had, let's add a grade in here of 0. Let's just make it a foot and call it MDN for median. You see what happens. And I'll then bring this down. There we go. So I've now created an island in my road if I wanted to do that. Now, to illustrate our road network where we got an intersection, we'd have to interrupt this curb structure in the middle of our road. But I'm just showing you can do all kinds of fancy things with this, and then put another curb out here of that same, did it keep our same numbers? Yep. And we'll call that one CRB2, face to the left. Sorry. Face to the right. Nope, should have been to the left. Anyway, this is all sort of screwing up because of this thing here. I'm going to take this out and this out. There we go. Now I'm back to where I was, except I'm facing the wrong direction. There we go. Now I've got that. Now, when you put in this curb structure, we start at the center, we put our grade in, we've got the curb. The next thing that we add to this is going to pick up on that top back of that structure. And I don't have to tell it that, it's going to automatically go to that. So I'm going to say grade, and I'm going to go at a positive 2, let's say make it a 2.5%. I'm going to go say 2 feet. I'm going to call that SW. That will be my sidewalk start. So I'm positive draining down into the road. I'm going to start here, and now I'm going to put in a flat grade across for my sidewalk, I'll make it, oh, let's make it, I don't know, 6 feet wide. I'm gonna call that sidewalk 2. So that's now gonna be the sidewalk. And then from there, I'll put one more grade and I'll put that one down. -2%. We'll go another 2 feet and we'll call that it's either toe or top of slope, depending on cut and fill. I just call it slope. So now at that point, I'm going to say cut. And there's all kinds of fancy things you can do with benching and stepping and setting in ditches and berms and all of that. But for now, because of our time constraints, we're just going to say a 3-to-1 on cut. Same thing on fill. We'll do a 3-to-1 fill. So now you can see it's going to come across here, go a curb. It's going to climb up that little bit till it gets to the sidewalk, and then a little bit down again, and then either go into a fill condition or go into a cut condition. All right, so that would be all you need to do if you're only interested in getting the top of the surface. That would be it. But while we're here, we're going to define a subgrade. Again, we would take this off our design. So I'm just going to throw these in here. I'm going to go through it fairly fast. And I'm going to say continue slope for this first one. It's a roadway subgrade type. And my horizontal offset, well, I'm starting at the center line, so that's going to stay 0 or blank. Now my vertical offset, and again, I'm going to look over here at units. I'm going to change that to inches. But now my vertical offset, this defines the depth of that pavement or whatever subgrade I'm going to use. So I'm going to say, make that 1.5. You don't have to put negative because it knows you're going underneath it. And how far out do it go? Well, if I'm going to match that pavement edge, I could just type 12, or I can go ahead and choose the one that I have. And if that edge of pavement should ever change, either through a some of these other transition tools that maybe it'll flare out to an additional turning lane, or you know, some widening, or it goes around through some other transition, it will follow the edge of pavement as far as that subgrade goes. And I'll give that material. That's going to be my top course. Super elevations, we won't worry about those yet. Now, if I see my different materials, you can actually define based on this material business. Let's see, it is asphalt. As far as the material that it's going to use, well, we'll leave it from that. And we'll say, okay, I'm not sure, Josh, if you had this set button for material. Typically, we just would give that a name, but I'll go ahead and call it asphalt, and we'll see what happens with it. All right, so now that's the asphalt. It's 1.5 inches down. I'm going to add another subgrade. And it's again going to have no horizontal offset. And I'm going to continue my slope. That means it's going to go out, and if that curb should travel, it's going to travel with it till it hits something, either daylight or another structure or another subgrade. And my vertical offset here. Now, if I've got a, what did we use before? 4 inches of base course.
Yep.
All right, so you would, you know, it's not asking you for a thickness here. It's asking you for how far from the top surface. So we've already got the 1.5. So we need to make this 5.5 to accommodate that as well. How far out does it go? It also Oh, keep hitting the wrong button here. It also goes to the edge of pavement. Edge of pavement. And material here is also going to be, there's an asphalt. As well. You know, you might would have stipulated those as two separate ones, like top course, base course. I'll say, okay, but they're both asphalt. Now, I'm going to put, so all right, so that's 4 inches of asphalt and 1.5 inches of asphalt. And you see there's, that's a 6-inch curb. Let's say I said 5.5. That should be not 5.5, but yeah, 5.5, 1.5, and 4 is 5.5. So I've only got 1/2 inch down to the bottom of my curb. So let's take 2 inches off of that just to see it visually, how it's going to affect something here. There we go. That's what I wanted to do to show you. And so now we're going to put stone under that, and it's also going to go underneath the curb, and it can go around to behind it here and then go straight up or wrap around, or however you normally put stone around your curb. So I'm going to do one more subgrade here. And let's put a good 8 inches. So 8 and 3.5 and 4.5. Is that what we have? 3, yeah, 3.5 and 1.5. So that's going to be 5. So this will be 13 inches. And this time it's going to go EP and an additional, I had that 18 inches. Now you should be able to put CRB in there, but it does, because that's a separate structure, it doesn't recognize a particular point on there like it does edge of pavement. So I had to give that distance. So I want to go EP plus, I know that was 1.5 feet. Now these distances are in feet. So EP plus 1.5 feet, let's go an additional 6 inches. So we'll say 2 feet. And if I choose my intersecting type as straight up, it's going to look like this. Okay, so you see it goes on out and goes straight up until it hits daylight. If I say continue slope, it's going to do that till it goes out and hits the cut or fill bank. And see, it doesn't need, it's not going to hit daylight because it's cutting away. This is all cut anyway, so I don't need to go any further than that. And then there's also this wraparound, and you give it a wraparound height in inches. Let's say it's going to wrap around and climb back up. Let's say 6 inches. Oops, let's try that. Wrap around, the wrap height. In inches. Oh, there we go. It wasn't quite enough. There's 8. So if we make that, because we have 8 inches of stone. So let's make it say 10 inches. So it goes out an additional 2 feet, comes up 10 inches, and then wraps back on itself. Okay. Now we've got under our side, that's our shoulder. We're not going to have any sub base under this, but there's under our sidewalk, we need to build that structure. So that point was SW, that point's SW2. So I'll hit my subgrade, and I'm going to go, I'll just use straight ups as my ties, and I'm going to offset this distance. It's not going to start at the center line. I'm going to offset it out to SW. And I'm gonna make a 4-inch thick to a distance of, I should be able to say SW2. I may have to put 6 in there. We'll see. We'll go to set and we're gonna go to concrete. And let's take a look at what that does. Yeah, see that builds my concrete slab. And I'm gonna put just sand under that one. So my horizontal offset, I'm gonna go SW minus half a foot. I think that will work. We'll take a look. So we'll start 6 inches before that. And if I do a wrap around of 4 inches, I'm just kind of flying here. So I now had, what was my sidewalk? My concrete's 4 inches. I'm going to put 4 inches of sand. So this will be 8 inches vertically. And my distance now is going to be SW plus 0.5. And that's going to be sand. Let's see if that does what I want. No, I was afraid that minus is what it didn't like. So let's take this out. Let's start it. Let's just put it directly under SW. Oh, it was SW2 plus 0.5, maybe that. It did, except for that last business. Let's do straight up and see SW minus SW2 plus. Well, it took care of the minus part. Oh, SW2 plus, but I've got to add that other half foot. So that's just gonna be +1. That would be that. Now let's try the wrap around. And the wrap height, let's make it 6 inches. I took care of it there, but it still went straight up there. So let's just do it straight up. I think I'm just going to take these little offsets out. Just have it match there. Yeah, so I've got sand underneath my concrete, stone underneath my asphalt, underneath my asphalt. I got my curb, I got my cut and fill. And that's sufficient. I'll say save and exit. So now I really have everything I need to generate that roadway. I'll say, and notice these optional output files in our settings. We say we wanted to kick them out. And those are those extensions or the suffixes that it puts on there. And I'll say, okay. And it says, here's my prompting now. It says, I've changed it to I want to run process. If I say yes, then watch what happens with it. So it draws all of this in with my cut and fills, does the contouring, does everything out. And I don't think, let me see if I was unable to read the template file. We'll take a look at that in a minute. Whoops. I wanted to make sure I didn't get any warnings about that width of our cross sections. I don't see any, so that part should be okay. Now, let's go and set up our layers a little bit here. What did we call? And C dash road. Major, but that's not. All right, so let's make our sidewalk. Oops, we'll make our sidewalks yellow. Oh, and our curbs cyan. Our edge of pavement. We'll take a little gray. Got these. Curbs. I want to find the here they are. C topo major and minor road. It really should have been in C road, so they're in different shapes. So our major contours will make red, and our minor contours will make sort of this lighter orangey looking thing. Maybe give that a little bit of width. All right, so that's going to show you everything that it's generated there. And if you let's freeze our existing surfaces and just look at this geometry in 3 dimensions. You can see how it's gone through there, tied everything back. There's my roadway with my curb, my sidewalk. And you can see the face of curb, the top of curb, the back of curb, everything's fit there. And I'll restore those layers. And now I'm going to look at that roadway surface. Wait a minute, before we do that, I'm going to go back to my settings, output options, triangulate and contour setup, set my color and layers. And now it's recognized from my template. I've got my edge of pavement here. I'll make my curbs that same color. My sidewalk, I said, was, say, that color. Sidewalk 2, that color. Slope green, and then others, let's make it a sort of a darker green. And yes, it's okay, it's okay. And I'll hit process again. Where did my turned off my original contours. I'll just leave them off for right now. But if I look at my surface now of that roadway design, my roadway surface that I built, those are those colors now that I defined in those output options. And you can see there's a nice crown on the road. Maybe see the crown a little bit better depending on how it casts shadows. There we go. Nice curbs. Oh, I see my sidewalk 1 is still, it's got that same color. So I need to go back Setup and sidewalk 1, I'm gonna make that same green. We'll just make it standard green. Slope with standard green. Okay, and now reprocess. And then look at my flip this time, and now you should see a little strip of green from the curb to the yellow sidewalk, a little strip of green, then to the cut and fill backs. All right, so there's your road as it was with the surface. If I do that one more time, let's turn my contours on 5 foot. So there's the contours as well. And if I add to that my existing ground, come back here and take care of that little glitch. So you can see, you know, where my road sits under it in areas of cut, it pokes through in areas of fill. And let's give that a little bit of transparency. So now you can see through it. And see the roadway underneath it. And then here's where it pokes out. You see the roadway full color. All right. So that's our basic processing of the roadway. And if I look at my reports button here, I'm going to take my output and take a look at what comes out of this report. Here's my total cut and fill, not very well balanced, but there's the amount of concrete. There's the amount of asphalt 1 for subgrade 1, subgrade 2. So that's my top course, my base course, my stone. I forgot to give that a name. I thought. Yeah. Then concrete and sand. Cut to fill ratio. And then here it tells me what templates we're using. So as we go from that station to that station, here's my total left curb, right curb, as far as the amounts there. Here's my accumulated cuts and fills, as well as the subgrades, all the way down through. And you can kick that out in spreadsheets, or you can, you know, look at it and study it and do whatever you want. Now, one thing that I need to do is I'm going to select that road and double click it. I'm going to edit that template again, and I'm going to take that subgrade 3. I never gave it a material. I want to give that some stone. Let's see what it looks like. Stone 8 or 9. Let's give it a stone 8. Save that. Exit that. Say okay. No, I'm not going to process. I'm going to change one more thing here in my colors. This outside, I want to match that one, which was 115. It's those outside little triangles. Save those. Yep. Okay. Reprocess. View the surface, roadway surface. Let's turn the contours off. And there. 1, toned it down a little bit. All right, so everything looks good. Oh, I know what it is. I've still got this opacity set. There we go. Yeah, that's better. All right, so I'm, doing okay with that as my road. And we're going to put a little crossing now, roadway. So if I simply draw a 2D polyline, I will put that on C road center line. And I'll go from here to here, maybe up to here. I'm going to add that as a road. I'll screen pick a polyline. There it is. I need to assign it. Now we had MLK Boulevard as a main road. This one's going to be Vista Drive. Nice and clever. Same thing for the profile. And this time I'm going to change that template series. I'm going to leave it there because I'm going to start with that. I'm going to edit that one so I don't have to keep taking some of the stuff out, but I'm going to take out this subgrade. I'm going to take out the sidewalk. And excuse me, I've got that part all stays the same. And then I'm going to come over here from that edge of pavement to my curb to that. I'm going to take slope away. I'll take the other edge of the sidewalk away. We're not going to have a sidewalk on that road. And this one we're going to change as 2 feet. We'll give that one a, say, an 8-foot swath. And we'll call that, well, let's go ahead and leave that one set to SW just so it'll match color-wise when we get the other one. So it's going to go back of the curb all the way up here, just 8 feet. It's just going to be grass. We'll save and exit. And oh crap. Can't really undo that. What I meant to do when I was doing that was do a save as. Let's say 12 foot. Let's say no curbs. All right, we'll save and exit. And now we hit our template button and we choose 12-foot no curbs for that one. Say okay, and I'm not going to process it yet. And I'll go back to MLK and I'll edit that. I'm not going to go to the effort of putting all those other subgrades in, but I will put this top in here for a minute. Let's say I'm going to go, we had 2 feet to SW. We added another one of flat. It was 6 feet. We called that SW2. And then we added one more at a -2% and went 4 feet and called that slope. All right, so we won't build the subgrades under that. but I just wanted to show you what happens when you've got one road with curbs, one that doesn't, see how it processes on an intersection. All right, so we could say okay to that, but I need to edit my center line file of my side street. It now doesn't have a curve in it. So I'm going to go to Vista Drive and edit the center line file. I'll fit a curve and we'll make that 250 feet. See what that looks like. Yeah, good enough. Save, exit. And now let's look at the profile of Vista Drive. And now you see the intersecting vertical lines, and it knows it starts on the ground over here. It goes to the ground over here, but it has to cross MLK Boulevard. So it pulled it up and it put in these little bitty vertical curves, one to transition into the cross pavement, one here with 0 length. And if you look at, see, there's the 0 length one. There's the 20-foot vertical curve to transition to the pavement. And you see the slope coming into that is 2.4%. Going out of it is negative 1.6%. Now, the reason it's not 2.0% is because I didn't cross that exactly at a 90-degree angle. So it's reading the slope across the intersecting line. But that's basically what it does. And so if I were to go back and edit MLK Boulevard and change its profile, you would see this road follow it. It pulls it up and down and makes it match. Okay, so I'm going to add a PVI right in here and a vertical curve length of, let's see what 100 feet does for me. That's nice. And I'll add another one right in here. Oops, let's see, add right in here. What's going on? Oh, it's not, I hit the edit button. Add, say in here, and we'll give that a vertical curve length of 100 feet. See what that does. Yep, and that gets me back down to the ground a little nicer. Okay, I'll save and exit. Now everything is set for both roads. Notice my intersection has been identified. I'm going to say, okay, I still am not going to process it yet. I've redrawn this center line. And if I select any of these things, what did I thought I said to thicken? Okay, so MLK, Vista, and then there's my target for my intersection. Now, what happens when I process this to all of our different components? So it's gone in here and taken my, it took this sidewalk and it sort of tapered it into a point over here. My curbs. Let's go back to Vista. This says no curbs. I did have a curb, so I'm going to take that curb out. And now I just want to change my subgrades to straight up to edge of pavement, straight up, edge of pavement. And then I extend beyond it with my stone. Let's just go a foot. Don't need it quite that far. And save that. Exit. Okay, now, yep, we'll process. All right, so Now my curbs come around here and stop. My little sidewalk does a little bit goofiness in there. And if I view my surface that results from there, you can see, yeah, I got a little bit of junk in there I'd have to straighten up. But my curbs come up to that part of the intersection and stop. Now I could tighten up my template drops in here a little bit. I think I've got them at 5 feet. I could turn processing off in the intersection to get rid of some of that, or I could even do something like this. If I select,
You mind if I interrupt here a second?
yeah, go ahead.
So I think you explained pretty well how the processing works for intersections.
Yep.
But I'm curious, most of the time when we get plans, they give us like an intersection detail with specific grades to meet along each curb line or whatever.
Okay.
Is there a better way to do that than just manually inputting them? Because that's what we currently do.
Yeah, I mean, well, I mean, you could do this, and again, we took this by default, but when you look at these intersections, if I double click this intersection, remember we put in those default distances for these transitions, but I have a front left, front right, back left, back right. And this is, I'm walking down the main line. I choose MLK as my primary road. And I'm going to hold the main crown. Let's see. I'm choosing edge of pavement to match. And now I've got these individual intersections. So if I'm increasing this way, my front right is this one, my front left is this one, and then my back right and back left, I think that's the case. If I look at my front left, it should be this one. If I edit the template transition, I can give it specific stations. If, oh, sorry, if I edit the profile of, yeah, see, that's my front left. There's that vertical curve. So I could then define that entire transition based on whatever your design gives you. Or you could even, put in, you can put in an artificial low spot to put a catch basin or something, so you would set that up based on what they give you in terms of the design. Let's say no, I'm going to save that. But you can do that for each one of those different intersections, front and back, change the individual radius values. I could say not tied to existing, just for those transitions. Let's say instead of 25, I had a 40 foot. Let's put all of these at 40. Maybe try, see what it ties. So that gets rid of some of that mess. All right, so now I'll save, process again, and see what happens. Yeah, I think we took care of a lot of that. We took care of a lot of those wrinkled up corners by increasing that radius value in there. But then individually, like I showed you, you can edit those profiles. You can give it station ranges. There you can see. how we said hold the main crown. So you see it comes up to that crown, and then this crown is consistent across here, but this is the one that changes. So if I'm looking at that as a roadway, you see it comes up and then it not only has to go up and across and down, but this road is sloping as well. So it's warping as we go through it. Whereas if we said in our transition, instead of whole main crown, if we said radial from curb and process that, and now looked at that same file. Oops, let's turn these, well. So you see how now it's taken it from the curb and it's blended it better. So this, even MLK has some transition across from its typical cross slope in there as we're crossing the intersection. So I turn those off. So now you can see there's a little bit of a surface interruption. It's because it took it radially from the curb all the way through the entire intersection instead of holding that particular crown. So I would probably I do like to hold my main crown, the main road crown. Now you could also, when you have the, see what that did for our ground slope. Yeah, see that put all of the warpage over on the sides and kept the crown of the main road intact. I do want to set that back from that to across the intersection. Now, so you have an intersection detail that shows you where all these things go. Typically, let's see if I station, see if those would be good enough for defaults. Yeah, there's my stationing there. I'll repeat it. And Vista. All right, now I would obviously, not have both of them start at 0, 0, but you get the idea. So you can limit, let's say this, you can change those limits on this transitioning in here. Template profile. I think that's where we can, if we limited that to, say, SW. Didn't affect that. You could start and stop your transitions at different distances. Station range is what I was looking for. Edit my template transition. Yeah, here it goes. So I'm on my front left. My intersection starting station at 0, 0. So that's where it starts up here where that curve radius would come back to the tangent. That's my 0, 0. And it would come around to, wherever that station value is in here. So if I ended the transition, say, let's try it 75. Now I'm on front left. Let's just put that down to 75 and see what effect that's going to have. Yeah, you can see it. You can see in the curb didn't come up to the same distance here at the midpoint of that curve. It stopped it short. So if I did that, let's try that instead of 75. Let's just put it to 25 so we really see a difference. Now, there's also these template grade tables that that gets into, again, that's more of our design. But you can put in each one of these individual template lines, you can specify at a different cross slope and a different transition length. Yeah, so there now you see I'm going to stop the sidewalk back here only 25 feet into the processing on that particular intersection. Otherwise, it'll go to the halfway point. I did it also for, let's just set that to, I don't know if it'll let me do it 0, 0, front left and front right. Yeah, see that stopped my sidewalk back. My sidewalk stops right here and it just picks up grass and goes at that point. So I maybe do that for each one of those. Process that. Oh, I took it all the way around in that case when I said 0, because it was going in the opposite direction. So in this case, it stopped it back here. In this case, it carried it all the way through. Let's see, 0, that's where it started. And stop. Let's just take a peek at what that looks like. That bled over, made the color bleed all the way out to there for those where that ended. It didn't tie itself back down. See profile now, transition. So that ends at 94,314. $91.73. Again, they would be even if it was a true 90-degree. 91.73. And then you should see that other 94,314. Oops. Of course, you could extend it beyond it as well. And that causes this little jump in here. All right, so and again, I've got a curbed road, and I would probably want to stop my curb back up there at the start. In front, left, and right. If I do this for my fronts, and then for this, I'm going to copy that. I think. Let's see what happens. Yeah. So that stops everything out here. Now you're probably, again, going to see that bleed into the surface triangles. And again, and that's just color of those triangles. It doesn't really affect the surface itself. Yeah, see that the color bled out because of those open places. And you also got a real abrupt chop right in there.
Hey, Ken, just so you know, I have to leave about 4:15 today. I got something to do.
Alrighty. So anyway, that's how we would process those things. Now, if we find, see, I've selected that center line. Now, if I pick that thing up and I'm going to move it from there to say over to here. See, it's trying to automatically reprocess it. I don't want it to automatically reprocess yet. I'll rotate it here. Now I'll reprocess. So it's going to go all the way across, find its new intersection, recompute everything. Now, if I look at Vista Drive, because I moved it and I look at its profile, you see, it still had that other one that I had in here. So I might tone that down a little bit. Come across there and then out here to the end. I'm going to put that back down to 0 as a depth. Notice there were some negative numbers in there because a negative depth is a height above. So it still found the intersection and still and pulled it so that it always crosses that at the same elevations going across it. So you might have to do some tweaking on that bit. Say, okay, yes, go ahead and reprocess. And again, you got some intersection tie down in here, some cleanup in there to try to take care of, but And again, there's that leak out. Now you can see how it's come across at a different location. It automatically finds those intersections and computes based on those values. Now we need to restation that. That's just there we go. Now pull that back up and put it into place. All right, so again, it's just a matter of when you find those intersections, modifying those based on your intersection template, or the other thing that you can do as well. Let me see how you would do this in a manual sense. You could come up to whatever station this transition needed to start at, and you could turn off. So that went from, say, 3 plus 55 out to 4 plus 70, 355 to 470 on MLK. Station and gap, I'm going to add three. I forgot what it. So I said 365. Oh, sorry. It's not a specific station. It's this gap. So 365 to 470, something like that. See the effect that's going to. Oops. Station gap. Okay, so I said okay. So in that case, you can see it completely stopped the processing through those station values. So I don't even have those edges of pavement and stuff generated through there, but you would use that to I did something. Three 65, so that stopped and it picked it back up right here, but it didn't continue the surface. Oh, that's what it was prompting me for. And I put that gap in there as it needed to build this as a separate detached surface. So if I take this out, process, and then, oops, put it back in, we'll add 365 to 470. It didn't prompt me for it that time. But that clipped out those structures. So here, if I 0 to 107, 885, 6, 462. 0 to 885.5. Zero to 99663. All right. So yeah, those stick. They stay until you. So if you change it, you got to go back and relook at it. All right. So now I stop. Wow. Let's screw that up. There we go. All right, so now you're back to the full transition. Now, a lot of times, especially if you're like subdivision street, you're going to have the same template, but you know, plenty of times you don't. Maybe that side street is a smaller. Instead of a 12-foot lane, maybe it's only a 10-foot. All right, since we're crossing sort of obliquely, I would make these radii a little smaller, or I mean a little bigger, and the tighter ones a little smaller. I don't know if you'll see that difference in the lane width. Because, yeah, maybe. Yeah. All right, so that's the essence of that. When you have intersecting streets, road network will take care of that. If you don't have an intersecting street, then it's just a single road that it's going to process through your site and give you all this tie down, everything good to go. And again, here's the value out of it, is this report where you get all of this information. And you can set what happens, what you choose in here. If I don't look at my subgrades or differences, just the areas and the cumulative cut and fill, you have to process it again, I think. And then I'll look at my report. So now there's my accumulated cut and fill by station. Every time I had a station drop 5, 525, 50. And you can see as you go through the intersections, you know, it breaks those apart and subtotals them for you. Okay. Let's see, there was one. The last little thing I wanted to. One last little thing I wanted to I wanted to indicate. Let's skip intersection. I don't know what effect that's going to have. Yeah, it just builds the roads separately. And they have some major issues. So I don't want to do that. There was one where if I looked and didn't tie, this is not what I was thinking. I had another thought I wanted to point out. Now this will, as you can see, it's going to still process the intersection, but it just doesn't it doesn't tie down from those points in there. Now you see it over in here because this main drag is actually underneath all of that. So it's not trying to blend it, it's just mixing the two together. Where the outside edge of this one, see how that's not connected, and this is not connected across there. So that's sometimes if you get too much of a wrinkle effect in there, you might need to turn those off and do some manual edits. Save that, process it one last time. Yeah, that's still gonna be a bunch of wrinkling in here because it's too tight of a transition. So, you know, we do a little bit of tweaking on that. Well, that's the thought I had. We were talking about the reports. It's completely escaped me, whatever it was. Well, in any case, and you can do some things in here. All of these optional files, you can set your topsoil removals, you can set template grade tables, template point profiles, template point center lines. And that's when you have something like let's say in here you wanted to have a little pull off area. And I'll draw one without being too precise. I'm just going to say draw from here to here. Maybe you're building in a turn lane, or you're doing like a little major bus pull off. And if I said that I wanted to create that, I need to turn that into a, well, it's a profile now. I mean, it's a center, a polyline. So on here, if I had that as a template point center line, I'll call this one just pull over. And I'll edit it. And my reference template that I'm going to use is that 12-foot with curves. So that's correct. And if I add the template point ID that I want to follow that line, I'm going to be my edge of pavement. Now it wouldn't have to be, it could be the curb, it could be any of those things, but I'll just make the pavement go, and everything outside the pavement's going to also go with it. Center line, I'll screen pick that. I will assign it. I'll call that pullover as well. And the side of this road to use it on is going to be on the left. And I'll say okay and save. Process, and you'll see the effect that that's going to have. So see, there's a case where we told the pavement to follow that line. Again, if I, I would put nice little radii in here so that I don't have all this chop going on here. I'm not going to take the time to do that part yet, but you can see the effect of that is this, and you get a bunch of this mess here because of that transition, but it basically well, if I had it without all of those things, Edit that and change the into pavement. Let's just push the sidewalk out. All right, so there. I still have a little bit of funkiness right in there, but you can see the difference is I told it to leave the pavement and the curb right where they were, but take the sidewalk and walk it around. And so it just continues that slope, but pushes it out. Now I can give that a separate profile if I wanted, instead of having that 2% slope up to here. I could change that, and I would have to create a profile file for this for that centerline alignment, and I could, control things like this. But usually what you would do with that is you would draw in, say, a stacking lane, or if you're transitioning from a single travel lane each direction and you want to add another lane, you could put it in like that, or you would actually have a template that had 3 lanes, 2 lanes, and you would give it a drop point. So that would be when you're doing these, instead of your design template, there's also a design template series. And if you use a series, then you would create the start and stop stations for the different templates that you're going to use along those alignments. Okay, so that's essentially that. And again, the rest is just refinement. And any particular questions? Josh, I know you got to go, and I think we guys were about 15 minutes over last night. We could actually end it at this point today, save yourself 15 minutes. But any particular questions, anything that you thought of now, or like I said, keep in mind, you've got access here. If you get into something as you're working on things, send me an email, send me a phone call, whatever. But any questions on anything at this point?
Completely unrelated to anything we've done. And if this is a long explanation, don't worry about it. But
Go Steelers.
if you have multiple layouts, is it possible to have like an automatic page numbering?
Multiple layouts. You mean down here at the
Yeah.
bottom?
Yeah, like to go print stuff out.
Yeah, there sure is. And it's more when you're doing, I'll show you that. When you, let's see, let's draw. So I draw a profile. Let me. Then I'm going to add Martin Luther King. All right, so I'd just say that as a profile. I'll say, okay, now, and all of that gets set up in here. So when you draw the sheet in paper space, you can set up here and say, I want to put it into paper space. And you have to have a template that lays that stuff out. I think we'll be able to. I'm going to be able to show it just with this paper size. Let's see what happens if we just hit OK. Yeah, sure. All right, so it's going to put, actually, it's going to all. Well, it all fit. It went from 0 to 16 plus. So depending on my scaling, I've got I'd have to do my page setup and set the origins correctly. But so this drew the grids, and you can see, let's get your color so you can see them. So if this were a different, what's our scale down here? 1 to 50. All right, so if we did that, say at a 1 to 20 scale, and then if we redo that profile, let me change the scale on that. Let's say a 20 scale. Say a 5-time new, say okay. Say okay. Now, oh, sorry, I keep hitting that button to do a screen capture. All right, and we'll put the layouts there, put the labeling there. It's set to manually put those locations. All right, so now I've done and just to get it to show in black ink. Let's turn that. Oh, all right, so now with these, there's 0 to 640, there's 640 to 1280, 1280 to 1920 to finish it up. And again, I'm just going to move that up here so you can see it against the white of the paper. And you can control all the grids and set them up for dash lines or what have you. And here it actually had to, because the scale was such coming around here, it had to break the profile. So there's a match line on that. So you have 1484 to 1484. So the elevations here are different than they are here because they had to shift it up to get it within the frame. So was that what you were asking about? We can put these in different layouts.
Yeah, that's fine. Thank you.
Okay. Yeah, and again, there's there's a bit of setting up that you'd have to go to. To get everything like you like it, like you wouldn't put these labels way up here. But nice thing is, double click that line in the profile drawing. What does it do? It loads up the profile editor. And you can also show, oops. Yeah, as you move along, of course, in plan view, I'm on the layout space, but you would see tracking the center line. You see that it's showing the sections. So it automatically outputted those section files. And now I'm tracking it even in my profile editor. And the nice thing about that is when you show these sections, it accumulates your total cut and fill that takes into account the side slopes as well. So that way you can tell I've got a total cut of 48,000, total fill of 8,200. So just 48,000 to 8,000. I would know that I could adjust my profile. So I'm in plus the cut. So if I, well, it's a little too much. Too sensitive.
Well, I got to head out, Ken, but you've been very helpful. So thank you for all your teaching.
Yeah, so there now is a case where, you know, you can see, well, I've got 5 million yards of fill, so that's a little bit, but you know, those are all things, and again, they're really intended for designers, but you know, there's ways to sort of help. And I'm going to say that. So there's ways to help, and there's a lot of complexity here that takes a lot of effort to get to. And again, you know, I've been doing this for, with Carlson directly after they've added the civil tools since 2006. Again, I'm trying to learn the whole product start to finish with the exception of the mining tools. And so I got to try to master as much of everything that I can. But as you get focused on your stuff, just dig into these tools a little bit and try your hands at those, okay? Anything else? Any other questions that anybody can think of? And Josh, you can take off anytime you need.
I'm happy. Thank you very much.
All righty. Thank you, sir. I'll send you guys links to the videos and your PDH certificates in a couple. It'll be a day or two once I get everything processed.
That sounds great.
All right. And so have a great holiday weekend, everybody.
You too. Thanks, Ken. Appreciate it.
You bet, Drew. Take care now. I'll go ahead and stop this share, and I will stop our recording. And